recording. So obviously with this being recorded, don't feel the pressure to put on your camera. Don't feel the pressure to raise your voice if you're not comfortable with that. But obviously this evening will be much more fun the more interaction there is. And I kind of like to take some liberties sometimes and kind of do like a, not a Q&A, but like a Twitch chat type of vibe, like we're really all interacting together. So that said, I'm going to give you a quick spiel, the boring stuff of who I am. But before we begin, can everybody hear me really quickly? Can everybody hear me? Just say yes in the chat real quick. Yeah. Perfect, cool. And then can everybody see this on the screen? Yeah? Cool, I think that's a yeah, perfect, cool. So amazing. That said, who am I and why should you trust me tonight and for the rest of the week to help you succeed in COM 308? So fellow student at JMSB, obviously my name is Ismael Pension, taking finance at JMSB, and I'm actually graduating this semester. One thing that I believe was really crucial and important throughout my time here was that I feel like some of the resources that we believe we need, some of the optics or like angles to take with some courses and or material is not provided to students. And that's exactly what I wanted to change. And I hope to do that through ISMA Helps and kind of with all the free content that I provide, but also through the crash courses to really give you like the actual no BS. How do we solve a question and how do we actually get the best grades possible? So this is exactly why I started this initiative, and I hope to be able to pursue it throughout the semesters and so forth. So that's kind of an idea of who I am. The reason why I think I'm a pretty good tutor with this is because I ended up getting an A in this class. I also had a 96% on the final. And it's not because, you know, I worked 25 hours. It's because I kind of just identified the questions to do and how to break them down in like relatively concise, bite-sized pieces. So I hope to share the same thing to you. In other terms, who I am as well is, you know, Dean's List student. Going to join a pretty good firm when I graduate. So I think I have a lot of things that I can share with you, and I'd be more than happy to share them even after tonight's session. So that's kind of the spiel of who I am and what I have to do and how I hope to help you. Now, in terms of you, a student, studying for your exam due on Saturday, right? I believe it's 16 questions, correct? For an hour. Am I wrong, or did they change that a little bit? I could say no, so.
Yeah, it's 16 questions, yes.
Okay, perfect. So 16 questions in an hour. It's not a lot of time, quite a lot of content to go through. And it actually did a breakdown. It's actually about, I believe, 3 minutes and 15 seconds or something like that per question that they're giving to you. And typically, it's a split of theory questions and then math questions, like computational questions, quantitative questions. Some of them will be fill in the blank, whereas others may not be. So the idea is, how do you navigate that? And I'm going to give you a few more tips there. But before getting to the exam and before going through, you know, the threshold here, is I want to share to you the different resources that are available to you to really succeed on this exam. All right. So what I'm going to do now is I'm going to share my screen to my Google Chrome thing, and from there we'll be able to kind of take a look at something here. So let me just open Google Chrome. All right. Okay, so you guys can see the screen. I'm writing a bunch of nonsense on the search bar. Quick yeah, just for fun. Like, can you guys see this? I wrote whatever. Okay, cool, thanks. So the first thing that I want you to look into are obviously on some really cheesy things, the ISMA Helps tools that are available to you. And I'm not saying this because it's me, I'm saying this because there's a reason why I use these things. There's a reason why I'm using them and I think they're useful to go. So if you go on my website, you know, if you go on COM 308, simple ISMA Helps / COM 308, even put it here. You go here, you're going to be able to find these two things. All right, free exam notes. Like literally, they're free. They're not going to rob you. They're not going to do anything to you. They're just additional notes that you can use to study, right? And I'm also giving you like strategy points on how you want to study for this exam. And once again, this is coming from one of your peers that got a 96 on the final, you know, fully legitimately, while also being, oh, by the way, I'm also a full-time real estate broker. I also have another real estate tech company. I have 5 courses. Like, everybody could do well if they have a lot of time, but how do you do so efficiently? So these strategy points are going to help you a lot. And then, yeah, there's like different, you know, definitions that are worth your time. So definitely worth checking that out. Then there's also the free practice problems. So with the course pack that I'm going to send again here in the chat, by the way, you can all download that. It also has a mock exam that we're going to do. From in there, you're going to have all these questions that you see here that are blank that are solved. So what I'm trying to say here is that if you do these questions with this document blank, and then you look at my step-by-step solved solutions, you're really, really well equipped to do well on the exam because you'll know exactly what is needed. So those are first-hand resources. And that said, I also have this for the midterm and the final. So even after today, if you don't want to come to a crash course, if you just want to do your own thing, you're busy, there's much more available resources for the next exams. And I know I'm talking a lot, but trust me, it's worth it. Then there's also blah, 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 blah. There's also videos on YouTube. And as cringe and cheesy as this looks, is that they're actually kind of helpful. If you go on my YouTube right here, at the bottom of the screen here, there's actually a bunch of different videos just catered to Comp 308. And especially for the first exam. Like if you want to figure out how to use your financial calculator, just take 5 minutes to check this out. It could help you. Same thing applies to like very complex questions. I've done it for all of them, kind of. So that's another resource available to you. Same thing will apply for your other exams. And then another thing, and I know I'm talking a lot, I apologize. I apologize. Feel free to tell me shut up in the chat if it's too much. But one thing that I would also like to share is that for those of you who've booked the crash course and who has access to the member area, there are also the recordings of previous semesters here. And I mean, this is an hour and a half of content. This is another 3 hours of content. Like that's a lot of stuff. Plus the recordings of tonight. You have almost 6 to 9 hours of additional content available to you to review. That's a huge game changer. So just take that into consideration as well. That's if you have the ISMA Helps member area. And then my final bit of spiel before the actual, like, how do we do well on this exam, like tricks, is that if I were y'all, I would go on your Moodle because I wanted you to know what are the most important questions. And you probably have one of these Comp 308 all sections right on the left. I would definitely go to that tab for Comp 308 all sections, and I would look at the tutorial questions. If you want to have that extra help, if you want to have that extra set of problems, within my crash course and within the solved practice problems I have available to you, I think you have a lot of, come on, like we would say in French, that is stuck. Like you have a lot of stuff. But, if you want that extra step, if you want more relevant exam-like questions, definitely go check that out. They're going to have a few more questions, a few more slides, but they're not going to be broken down into step-by-steps, but at least you're going to have exposure to more problems. I really do recommend doing that, okay? So that said, that's the end of my spiel. Now we can actually see how do we ace this exam and what are the other elements worth checking out. So once again, we're coming back to this. So that said, for your exam, what I would recommend, also, by the way, don't do Wiley questions. A lot of you have, when we discussed, you told me, hey, I'm doing Wiley questions, I'm doing this, I'm doing that. Scrap that. You really want to focus on the tutorial questions, okay, from Moodle and or the crash course pack questions. Really, it's a total game changer. Those are what you're going to see from your exams. And there's probably a reason why they're here, right? Wink, wink. There's a reason why I took those questions specifically. And I'm also going to tell you which questions were from last semester's exam and the one before that, such that you could have like an alert there. Then just last point, in terms of what's available to you in this course pack that I've added into the chat, as you can see, there are questions, right? There are questions and they're solved, step by step. This is exactly what you want to look at when you're reviewing questions on your own. How do we go about this and what's the rationale behind it? Definitely a must recommend if you want to go about it, about doing problems. All of these questions were from past exams. It's really worth checking out and they're all explained step by step. Okay, another thing that I'm going to say before I take a breather for 2 seconds, it's if you go at the top, actually, if you go at the top, there's also a formula sheet that I've added. Just give me a sec. So if you go here, I've added a formula sheet. You don't have to use this on your exam. In fact, I don't recommend you do. I recommend you make your own. It's the best way to do it. But I've added different formulas that are crucial to your exam, like that just makes sense and that makes things easier for you. And if we zoom in, you also see that I've added a timeline. A timeline, like for example, per different types of questions, there's different timelines to consider, and this allows you to do so. So definitely a must check in my opinion. Okay, the final point, last but not least. The final point before we begin this crash. Yeah, amazing, Pronto. That's an amazing question. For your cheat sheet, you're literally allowed to put whatever you want on it. What I did is instead of just putting formulas, I would probably try to look at the questions that were the hardest for you and kind of write down the steps by steps on your cheat sheet, like on one section, just to kind of have that active recall when you're on the exam. And also doing your cheat sheet, kind of focus on the harder parts and like the macro parts, because it's going to kind of give you like another opportunity to remember things as you're studying. But I really do recommend you add the basic formulas that are needed, and then you add the harder problems, like a little screenshot of the harder problems on your cheat sheet. Really, really, that's what I do, and it's really helpful, especially when you're not sure what to do. So now, finally, in terms of best practices for the exam, and then we'll start, trust me. In terms of best practices for the exam, I definitely do recommend one thing. On the exam, you're going to have 16 questions, okay? All right, and they're going to be multiple choice or fill in the blank. What I would recommend if I were you, within the first minute or the first 2 minutes, go through every single question. Just press, look at them, have a quick idea of what's going to be on the exam. The reason why you want to do that is because you want to get through the questions that you know already. Some questions will only take you 1 minute to do, right? So if you're able to, let's say, do half of the exam, right? So 8 questions, you're able to run through, right, in like 20 minutes, right? You're able to do 8 questions in 20 minutes such that there's only another 8 questions left, and you have literally only 8 questions left, and you literally have another 40 minutes for 8 questions. Now you have, if we just do quick math, right? Like if you have 40 minutes and there's 8 questions left, you have 5 minutes per question rather than the 3 minutes per question that you have initially. You almost have double the time, right? So I really do recommend survey the exam, look at the ones that seem the easiest to you, get them out the way, and then sit down for the next 40 and focus on the harder ones one by one. That's how you maximize your odds of doing well on the exam. A lot of students, including myself on the first exam for Comp 308, kind of decide to stay stuck on one question at a time. And that's not the right way to do it. Anyways, that being said, do you have any questions on strategy or like best practices to actually take the exam before we begin the questions? If so, you could always send me a text. But any questions about that, or we can move on and do some of the solving? I think we should be fine. Yeah, I think we should be fine. Cool. So that said, I hope everybody has their their course pack open and available, because we're gonna start solving questions together. So let's do this. Just give me a sec. All right. Just gonna zoom in. Perfect. Just putting the chat smaller so I have more spaces on my screen. Okay, so bonds. Bonds are always so fun. A lot of students seem to not like them for whatever reason, and I can tell you, I definitely feel your pain. It was the same thing for me here. So question 1 is about bond valuation. Bond valuation is, a classic. So the first thing that we're going to do is we're going to read through the question together, kind of make sense of what's up, what's the scenario we have at hand here, and from there we'll be able to solve it together. So bond X is a 10-year semi-annual coupon bond, which was issued at par 5 years ago. The yield to maturity 5 years ago was 6%. How much does bond X is worth currently when the yield to maturity is 8% now. Please note that the face value is equal to $1,000. Okay, so the way I like to do this is I like to be interactive. So can you tell me, and we're going to go through it together, can you tell me what are the important parts? You could write it in the chat. What are the things that we should probably highlight within the prompt, or things that we should kind of use in our formulas or calculator? What do you guys think? So YTM equals 6%. I like that. Face value. Okay, cool. Amazing. So just here it says 5 years ago was 6%. So that's probably something to consider. The face value at $1,000 is super crucial. And semi-annual. I love that. Yes, Charles, that's exactly it. Very important. And 10-year bond. So n equals 20. That's good. That's good. Where is that? So 5 years ago plus 5 years ago, 10 years. Okay. So those are all amazing points. Those are all great points. I mean, that's what you want to know. I'm going to highlight a few other parts that are really, really important. Is as Charles said, is that we have a 10-year bond, right? We have a 10-year bond, but just please remember that this happened 5 years ago, okay? 5 years ago. So what does that mean for us is that we're kind of further down within the timeline, and that may mean that we need to adjust ourselves. Very, very important for you to kind of understand that. And you'll see why in just a bit, because on the exam, when you're stressed, you may jump over that fact. We really need to understand our timeline, okay? So that's really, really good to know. Now, that being said, another point that I would like to see here is that before all questions that you do, extremely, extremely important thing to do is to know what formulas you can use, right? Because most often, especially at JMSB within your undergrad, questions will always be a type of puzzle. And often enough, you have a lot of bits of information. We're just missing a few variables. So what we're going to do now, if you don't mind me asking, we're going to use a bond valuation formula. Okay, and the bond valuation formula is crucial. It really does help, in my opinion. So let's write that down. So we're going to use a bond valuation formula. And then I'm going to ask you guys, or all of you, to tell me really quickly what are the points, or essentially you're going to help me add the points here to our bond valuation formula. All right, and at the same time, we're also going to build a timeline. You do this on an exam and you have the answer in 2 seconds. Of course, you could still use your calculator, but I kind of like using the formula because sometimes it helps you go through the harder parts. So one thing to consider here is, what is our C? Can somebody tell me what is our C? What do you think that would be? No pun intended. What would be our C here if we're looking at our bond valuation formula? What would be our C? So C is the coupon payment. Amazing. Yes. So C is the coupon payment. Now, how do we discover a coupon payment? How do we do that? How do we find a coupon payment? So what is our coupon payment here, if you don't mind me asking? What is our coupon payment? Somebody could raise their voice or write it in the chat. What do you think it would be? Then I'll tell you how we go about finding that. So what would be the coupon payment? So Rosalie says 10% times 1,000. Gayur says 6%. And then Charles says $60 per year, but semi-annual, so $30. And that's an amazing, amazing answer. All the answers were good, but that's a really good answer. Well, it's the correct one. So when we want to find our coupon payment, what we need to look at is something extremely, extremely important. Okay, we could use the following to find our payment. Okay, so to find C. So to find C, you could use the following formula, or you could also have an intuitive sense to it. What you're going to do is you're going to do face value, all right, times the coupon rate, all right, times the coupon rate divided by the payment frequency. And I'm really annoying because I'm going to ask you another question. Can somebody in the chat tell me what's the face value? We're going to go one by one. What would be the face value? Pretty straightforward. Right? Face value is 1,000. Amazing. But now the question is, how do we find our coupon rate? How do we find our coupon rate? And this is something really important for all of you to understand. In a question, And you could write this down as a note, or you could look at the recording later. In a question, when we tell you that a bond was issued at par, when we tell you that a bond was issued at par, that means that the coupon rate was equal to the yield to market. So when a bond was issued at par, that means that the coupon rate is equal to the yield to maturity, okay? And what's really interesting here is that they tell you that it was issued at par 5 years ago, all right? It was issued at par 5 years ago, such that coupon rate is equal to YTM. So can somebody tell me, oh yeah, no problem, I'll explain the YTM in 2 seconds, but just before we do so, they tell us here that the YTM was equal to 6% 5 years ago. So when the bond was issued. So by that definition, or by default, what is the coupon rate? If we know that it was issued at par 5 years ago, and that 5 years ago, YTM was equal to 6%, the yield to market, or yield to maturity, sorry. What is our coupon rate then? I need 2 more answers. Okay, I need one more answer. Just one more. We got 2 right now. We have Goyor and Sarah. I need one more answer. What is our coupon rate? Thank you so much, Johan. Thank you so much, Sarah and Goyor and Pranto. Thank you. So yeah, our coupon rate is equal to 0.06, i.e. 6%. Now, quickly to explain what the yield to maturity is, the yield to maturity is essentially the expected coupon rate within the market. All right. There's like when we study economy, when we study supply and demand, typically there's an average coupon rate that's given by different bonds, right? Similar bonds. Okay. So when we're looking at the yield to maturity, we're just looking at the average coupon rate given. Okay. And we're looking at a very specific scenario. Exactly like the standard. Like Sarah said, like the standard coupon rate. And every bond sometimes, well, they may decide to be different than the standard, okay? So that said, now we have our face value, we have our coupon rate. All that we're missing is the payment frequency. But what if the years at par or RTM was different? How would we find it? Yeah, it's not gonna happen. So typically, it's really straightforward, like in this question, Pronto. If we ask you, hey, it was sold at par 10 years, 5 years, or whatever years ago, and they give you the yield to maturity, then yield to maturity is equal to coupon rate. Like there's never a different scenario or a tricky scenario in terms of finding your yield or finding your coupon rate. It's typically very well said. Like the hardest it could happen is like what we have in this question, okay? And finally, just because I am taking a little bit more time, but finally, what is our payment frequency? What is our payment frequency? I mean, this one's pretty straightforward. We have a semi-annual bond. So how many times are we having a payment in a year? How many times are we having a payment in a year? 2. Amazing. Yeah, this one's easy. I think we all got it here. So yeah, 2. So then can somebody please tell me what is our C? I know I'm taking a lot of time, but what is our C? $30. Amazing. So our coupon payment is equal to $30. Cool. Amazing. Now, the other part that we need to look at is what is our, as you can see here, what is our KB? Now, KB is a very exotic way to say what is the yield to maturity on this bond, okay? So KB, all you need to understand for KB, or just the yield to maturity, is that you need to take the YTM today, like right now, divided by the payment frequency. Such that, in this case, I'm going to be annoying again. What is our yield to market, our yield to maturity, sorry, right now, today? If you look at your PDF or you look at the screen, what is the yield to maturity right now? It's written in, there you go. Thank you, Goyor. It's 8%. And there's a payment frequency of 2, such that KB is equal to 0.04. All right, that's the idea here. And finally, now that we know this, and I'll highlight everything that we know. So we know this, and we know this. The only thing that we're missing is this value. Now I'm gonna ask you with a wild guess. What is F? What do you think F would be? Just for fun. You know, what do you think F is, you know, within the scope of this question? That's a good guess, but it's not that. There's another thing that starts with F. Thank you, Charles. F is the face value, okay? F is face value, such that, whoops, sorry about that. My screen kind of closed on me. Give me a sec, such that F is equal to, just give me a second, my iPad is gonna reconnect. Sorry about that. There you go, such that F is equal to 1,000, okay? So now we have all the missing parts that we need to solve this question, such that all we have to do now, we have all the missing pieces of our puzzle. All we have to do now is plug them in. Now I'm going to be annoying. I'm going to ask you to give me the answer. What is PV equals 0? Actually, we're missing one thing. Sorry about that. We're missing N. That's on me. We're missing N, which is right here. And we're missing N, which is right here. Now, the only thing to consider here is N, right? I'm going to ask you, what do you think N is in this specific scenario? So Devon says 10. Yohan says 10. Okay, I need two more answers. I'd go with 20. I'd go with 20. I'd go with 20. Okay, so we have like kind of a disparity within the group. And this is, honestly, all of you are probably on the right path. The answer here is 10. N has to be 10, and I'm going to tell you exactly why. N is 10 because the bond was issued 5 years ago, such that we're only considering today till the end of the bond's life. We're not considering it from the very beginning of its issuance. We're only considering it from today, because we're giving you a scenario of 5 years ago. Let me draw you a timeline such that this makes more sense. So that's an ugly line, but sure. Right, so this is going to be the maturity, and this is going to be the issuance. So we have 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, 7 years, 8 years, 9 years. So we have 10 years, okay? So we could say 1, 2, 3, 4, 5, 6, 7. Okay, so we have 10 years, but the thing is, we know we're only starting here. Our timeline only begins from year 5 because the bond was issued 5 years ago, such that we can't consider this portion as part of our N. Our N only moves forward from today to maturity. And because there are 2 payments per year, we're going to do 5 years multiplied by 2 payments per year. And that's going to give us N equals 10. So obviously I have a more detailed and cleaner timeline, and that's available in your course pack if you go up. Questions that are a little bit already solved within my course pack, I don't spend too much time with the drawings, but for questions that aren't, I will be much more like cuter with my timelines. But I really need everybody to understand why N is equal to 10 and not 20. So Guillen, Pronto, Guyur, Charles, do we understand why N is equal to 10 rather than 20? So Pronto, got it. I really need all of you to say yes or got it. And if you have a question, just let me know, right? When we look at N, we always look at it from today to maturity. We don't look at it from the past. The past has already occurred. So we can't consider that within the price of the bond. So that said, can I ask you really quickly to give me what PV would be? With all these different elements, with all these different things, what would be PV equal to? All right, I'm gonna write down the formula, and I need 2 more answers. I need 2 more answers, not just Charles, and I'm gonna write down the formula at the same time with the correct inputs. Okay, so we have 2 answers. Just for those who aren't sure what to do. Just going to give you the perspective here. Okay, so that's the formula, and then you just have to input these things within your calculator, and it's going to give you the correct answer. We have Charles, we have Devon with an answer. I need one more answer, and then I'll tell you if it's correct. Although you could probably see if it's correct if you go up the course pack. One more answer. Did somebody else get to a different number? Did somebody get to? Okay, good. The answer, yes, it is definitely 918.89. And before we did spend like 10 minutes on this question, but it's a fun one. Bonds are typically the trickier ones. So yes, the answer is 918.89. So A. That said, are we all okay with this question? If you have a question now, if there's something that you didn't understand, just let me know. We can spend a quick minute on that. So are we all okay with this? I need to see like 4 yeses. And if you have a question, just let me know. So I see you're saying yes, Sarah saying yes, yes, yes. Okay, good stuff. Amazing. Okay, so Rosalie, an amazing question. And yes, there is a part on bonds when it comes to theory. And let me just give you a quick perspective on what it could be like. Let me just show you. And perfect. So the bond yield curve looks something like this. Okay, so we're going to look at convexity for the bond yield curve. This is a little extra for all of you because this could definitely be on the exam. Let me just see if I could find something. Let's get that for y'all. Yeah, so the bond yield curve, essentially what you want to know, and there are 2 things that are really important, is that a bond yield curve is always downward sloping. I'm sorry, my iPad keeps on disconnecting. It's weird. Sorry about that. But yeah, the bond yield curve is always downward sloping. So what does this mean is that as your x-axis progresses, so as this gets bigger, your y value gets smaller. Okay, that's what we mean by always downward sloping. Okay, another really important part is that when you're looking at your bond yield curve, is you know that the higher the yield, okay, so this is the yield, that's your x-axis. Here you have your price. Dude, I do not know why my iPad keeps on disconnecting. I'm so sorry about that. But the idea here is that this is your price, okay, and this is your yield. So essentially, when your yield is really high, the curve will flatten out, right? It kind of flattens out to a certain point. But when the yield is really slow, the prices get really, really high. That's something that you want to understand, okay? That's really the only real elements that I would stress about when it comes to this. If you see a theory question that you have within your notes or something, ask me. But this is something that has been on the exam 2 years ago, and you just really want to know that 1, the curve is always downward sloping, and that the curve is flatter when the yield is high, and then obviously the curve is not flat when the yield is low. So kind of vice versa. You want to know one, and you want to know the other type of thing because they are proportional. But that's really all that I would stress about when it comes to that. That said, let's look at this question. This one is really, really fun. It's a personal fave on my end. Not fun, but it's interesting. It's definitely interesting. So that said, let us read this question together and make sense of it. So this one, we have the classic. So assume you are to receive a 20-year annuity with annual payments of $50. The first payment will be received at the end of year 1, and the last payment will be received at the end of year 20. You will invest each payment in an account that pays 10%. What will be the value in your account at year 20? All right. So this is an interesting question. And this is something that's, it's like, this is an exam question. You know, it may not be exactly like this, but you will have something within the same optic on your exam. And you're going to realize that this is actually a set of free points. And I would definitely go grab them if I could. So with that said, what we're going to do is we're going to just identify the main variables or the main pieces of the puzzle that we want to understand. But another thing that I would like to say, and this really does depend on how much you've been studying and how comfortable you are with visual elements. But when I see a time value of money question, if not all 308 finance questions, there are two things that I want to do. I want to be able to identify all the missing pieces to my puzzle, i.e., I want to be able to look at the formula that I'm going to use and see if I have all these elements within my prompt. We'll do that. Second is if I have the time and if I'm really visual and I understand the process, I think it's crucial to build a timeline. When you're doing TVM, time value of money, it's crucial to do a timeline if you can. If that's too much stuff to do within the 3 minutes or 5 minutes you're going to allocate to the question, don't do it. But when you're practicing, I definitely do suggest doing this because it's going to build an intuitive sense to these questions. Anyways, so assume you are to receive a 20-year annuity. Okay, so the 20-year annuity is extremely important. The 20-year annuity part is our end. It's the amount of years that we're looking at. It's the amount of periods that we're looking at. So definitely something to underline or highlight. And then we have annual payments of 50. So I think it's very clear that 50 is our PMT, 50 is our payment when we want to plug that in our formula. The first payment will be received at the end of year 21. So the first payment will be received at the end of year 21. This is crucial because we want to know what type of TVM formula we should use. So when we say, this is really important, when we say that a payment is to be received at the end of the year, what are we looking at? Are we looking at an annuity due or are we looking at a normal annuity? Could somebody answer that in the question? So Gear says ordinary, Sarah says ordinary. Maybe another point just for fun. Maybe somebody could say, you know what, I think it's annuity due. Simbi says due. So you see, that's why I wanted to ask that question. Because if you look at my formula sheet within this course pack, if you go back to page 14, you're going to see exactly what checklist you need to go through when you look at a TVM question. Here, we know that we're dealing with regular payments, and we know that this payment is done at the end of the period. If a payment is done at the end of the period, then it must be an annuity, a normal annuity, okay, an ordinary annuity. It's not an annuity due. So if you see at the end, all right, if you see this, it has to be a normal or a ordinary annuity. Now, the reason why that's important is because now you know exactly what formula to use. You know that you're looking at a simple formula. You're not going to look at a formula for a perpetuity or an annuity due. I just think that's extremely important for you to be able to identify. Now we're telling you that the last payment obviously will be at the end of year 20 because we're looking at 20 periods. And we tell you that the interest rate or the rate that the account pays is 10%. And we're asking you, but hey, what will be the value at the end of year 30? All right. So those are all amazing points. Really quickly, just understand that we start at T1, our payment is equal to 50, and we're going to finish at T20. However, we're still talking about T30. So what does that mean? And we have K is equal to 10%. Okay. Another thing that I would probably like to consider here is that we should build our timeline. And now that's exactly what we're going to do. Okay. That's exactly what we're going to do. And obviously, if we're looking at the end of year 30, let me ask you a stupid question, or not a stupid question, but just a question. Are we looking for the present value of a normal annuity, or are we looking for the future value of a normal annuity? Okay, so I'm glad to know that we're all on the same page. If we're looking into the future, we're looking at the future value. Just that has to be clear. All right. So step one is to build our timeline. All right. Now you don't have to do this, but for now, I think that is something it's a really good skill to have. It's going to help you throughout your whole parcours in finance. Oops. Okay. So this seeks to identify the different parts of our question. So we're at T0, have T1, we have T2. I think we could all agree that the payments are going to remain the same up until T20. That's an important date for us. So we're going to skip a few dates. So we're at T19. We are at T20. So year 20. T21. And we're going to skip a few dates to T29 and T30. So now I'm going to ask you, I'm going to do something on the screen and you're going to tell me what do we need to put. So our payment here, what would be our payment at T1? Just for fun. Payment is equal to, with this question, what will it be equal to, the payment? Is it equal to 10, 50, 60, 90, a million? Amazing, thank you. I think we could all agree that we have a payment at these different periods. Now, obviously, our payments are going to continue between T2 and T19. Now, let me ask you, we have a payment that finishes at the end of year 20. Do we also have a payment at T21? Should I put 50 here? Yes or no?
No.
Yeah, thank you. Yes, the answer is no. We do not put a payment at T21. Okay, we do not put a payment at T21. The reason why is because we did 1 payment, 2 payments, 19 payments, 20 payments. We did our payments, you know? We did our payments. Imagine a world where the bank takes more payments from you or a car loan takes more payment than you. That would suck. So we're going to apply that same energy here, okay? So payments are done at T20 because we're dealing with a normal annuity, okay? So that's really important to know. That said, I think we're going to define this section from T1 all the way to T20 right here as part 1. Part 1 because this is a normal annuity. Okay, that's really cool. Now, this question has another portion to it. It's telling us that we're going to leave our money into this account for an additional 10 years or until the end of T30. So what do we need to do now is we just need to put our little finance helmet on and understand that we're not just going to leave our money in the bank to not get interest. This question is telling us that we're going to leave that money in the bank for another 10 years to earn interest. So we're going to apply an interest rate for every single year up until T30. Now, what is this interest rate that we're going to apply? What does the question tell us? Is it 3%, 5%, 20%, 10%, a million percent? Exactly, it's 10. So every period until between year 20 and year 30, we're going to apply. Why aren't we applying the interest during the period or like between period A? Like, you mean like in this section? Yeah. So the interest is already going to be applied because we're going to use a formula. The formula is going to apply the stuff for us. I just meant like, obviously, if we're getting payments every single year, we're going to apply, interest to it. I just wanted to divide these two sections, and that's a really good point. So if we look at this section here, we're looking at section B of the problem, and this is just compounding interest. The reason why I just put it as 10% is because portion B is actually the easiest portion of the question because the formula is literally one line. Whereas for portion A, we kind of need to remember the formula and we need to apply the different pieces of our puzzle. All right, so now we understand that we have two portions to this question. We have the normal annuity portion where we need to, be a little bit more complex, and we have the compounding interest portion of the question, right? Because we only put payments up until here. So it would make no sense to use the normal annuity formula here, okay? That's the reason why I use the timeline, because we're only going to use our formula from T1 to T20, and then we're going to use compounding interest from T20 to T30, okay? So that's just something I wanted to make extremely clear. So for the portion A, what we're going to do, and I'll use the same color just for fun. So for portion A, we just need to use the following formula. So for the normal annuity. And as I write this, I'm going to just do this for you. So we're going to have you and payment. Sorry about that. This weird emails coming in. Okay, so now for the first section, I'm just going to ask you to participate really quickly. So what would be our end here? What am I going to write here? 10, 20, 30? You don't have to do this on an exam, but I'm just asking you for good measure. What are we looking for? Are we looking for future value? There you go. We're looking for future value 20, right? Because period A, the normal annuity period, stops at T20. Now, what will be our payment? What will be our payment? Is it 10, 30, 40, 50, 60, 70? It's 50. Amazing. Now, what's our denominator? What's our K? What are we going to put as our K? I need somebody else than Guyot and Charles to answer. I need somebody other than Guyot and Charles. So what will be our K? What are we going to put as our interest rate in our denominator at the very bottom here? What are we going to put here? What would be our denominator? Johan, thank you so much. Okay, so now we have this. And we know this is 20. And we know we have the following. So can somebody tell me, somebody other than Charles, Guyot, and Johan, can somebody tell me what's our future value at year 20? What is our future value at year 20? So we have $50 payments up until year 20, so T20, with the following formula. What would be our answer? A little bit more at the same time. What's our answer? What would it be? Sorry. Que sera notre réponse? I wonder if this is going to work. Okay, we got tomorrow and an answer. Does somebody else have an answer? Is this the correct answer? Simbi says that as well. I need one more person. You might be a millionaire if you answer this correctly. Okay, you get the same. Perfect. Yeah, the answer is this exactly. Thank you so much. So it's always okay, by the way, if there's like a rounding error, that's not a problem. They actually let you have some sort of like standard error when you answer. But yes, this would be future value at year 20. But we're not done yet. There's still the compounding interest portion that we need to add. So let us do so. Just for a visual representation, what we got here, okay, this is our future value at year 20. So right here, we actually have the thing I asked you to compute. Okay, now all that is left to do is to compound this amount by 10% every single year. Okay, so this is the easier part. This is where it gets fun. All right. So now for B, compounding interest. And you'd be surprised how simple. It's not even a formula. This is honestly just understanding what to do. So of course we have future value 30. And like with anything, when it comes to compounding interest, it's a very simple formula. And you know what? I'll even take the time to show you what the formula is. Anytime you just want to compound interest with a specific amount that's not going to change over time, you could use the following formula. And you could match that formula to all the different scenarios that you may have. Let me show you what I mean by that. So let's say you need future value n. And you have, you have P being, this means principal, like you have this amount, this random amount, right? All you have to do is you have to do this plus this to the power of n. It's as simple as that. And that's exactly what we're going to do here, right? So in this case, We have FV30, and we already know we have FV20. And we know we have our interest rate. What's going to be our N? Just for fun, can somebody tell me what will be our N if we're going from year 20 to year 30? What will it be on some funny stuff? Don't make me put the music again. Okay, cool. It's 10. There you go. So that said, this will look like this. Such that the future value at year 30 is equal to what? If you plug in all those good numbers inside of your calculator, what would be the answer? What will be the answer? Okay, we got one answer by Charles. I need another answer. I need another one, just one more. That's all we need, really. Yohan, I need the decimal points. Come on, I need the decimal points, bro. What is going on? If you put that on the exam, that's wrong. There you go. So yeah, that's the answer. Cool. So once again, just for reference, it's really important that you understand is that what we just received is our future value at year 30. Okay, so that's kind of how it works. So that said, that's the way we would go about it. Before we continue, are we okay with this? Does this make sense? Was this simple? Are we happy? We see this on the exam, we're ecstatic. We know we're gonna get a great grade. Yes, no, if you have a question, let me know. Now's the time. Perfect. Okay, yes. I need like two or three more people saying yes. Okay, cool. Good stuff. Amazing. Happy to hear that. Okay, now we have another one about time value of money. This is the good stuff. So let me just stuff here. Oh, why aren't you showing us a calculator trick? I can, and I'll show you actually. So for the first question, if you want to use your calculator, Devon, can you just, all you need to do is go up the course pack, and there's this exact question with the exact inputs you need to put it within your financial calculator. I just rather myself use the formulas because you can never go wrong with a formula. You can't misclick with a formula. But if you go up, the course pack, you'll see the exact inputs for your calculator. Sorry. Okay, I just got it. Yeah, you could definitely use your calculator. Like you could put payment for this. You could put N as being 20. You could put IY as being 10%. And then you could literally just press compute FV and it's going to give you the same amount. It's really up to your liking. I'm going to give you the most things possible, the hardest way to go about it, such that you're able to understand. But yes, you could definitely plug this in your calculator. It's like a mortgage or anything else. It'll give you this correct amount, and then you could do this. It's up to you, Devon. That's a really good point too, is that if you feel more comfortable using your financial calculator, go for it. There are no rules. But if you want to, use formulas, then you could go for that as well. For this crash course, I'm going to go through formulas because as you progress through harder questions and harder courses at Concordia, and maybe even your master's or when you get a job, it's really important that you understand these things because it allows you to make some really cool stuff and some really cool models, like especially on Excel. Anyways, so that said, so yeah, the Princeton case, it's the good stuff. It's the good stuff. It's definitely a fun one. And it's going to require y'all to apply some thinking outside of the box. This was on the exam. I believe it was a year ago. If I'm not mistaken, I could be wrong, but I believe this was on the exam a year ago. And we're going to go through it together. This one is definitely one of the more complex TVM questions. It requires a little bit more heavy lifting, but not in terms of the computation, but more so in terms of the understanding. And that's what we're going to try to do again. It's really important to understand the different dynamics at play but it's not hard, trust me. It's just a little bit more complex in terms of like the different understanding elements that you may need. That said, so we have a 6-year-old. We're all parents of this beautiful 6-year-old. You know, we'll call him Liam. Okay. We have the 6-year-old who wants to go to Princeton, big dreams, you know, and we know that in the future, when our kid is going to go to Princeton, it's going to cost us 30K per year for 4 years. All right. So we know that this dream of Liam, it's going to cost us a future payment of 30 grand per year in the future. So we could even write this in blue there. So future payments equal to 30K year. All right, let me just change this as well. Use this one. Okay, so on our kid's next birthday, all right? So a year after that, all right? Oh, it's on her next birthday. We'll call him Liam. Okay, anyways, on her next birthday to start putting money into an account, paying 14% annually. So on the next birthday of our child, we're going to start putting money aside, okay? And we're going to deposit the same amount of money every year. So you're going to deposit the same amount of money every year until her 17th birthday. Please remember that the child is 6 years old right now, okay? 6 years old. And on the next birthday, that's when we start to put money. And at her 17th birthday, that's when we stop putting money in, okay? The first tuition payment will be payable on her 18th birthday. The second on her 19th, blah, 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 etc. So I think you could see the trend here. Important to see that this pays 14% annually. So what we want to see here is how large will our payments, our annual deposits have to be, right? So this question tells us only a few things. There are a few missing puzzles, a few missing pieces to this puzzle. But what we do know is that we're going to seek our annual deposits within this account. Now, can somebody tell me if we had a formula, what these annual deposits would actually be? Like, what would we call this if we had a formula? Would we call this PV? Would we call this K? Would we call this N? Would we call this KB? What would we call this? I have 2 answers in the chat, but I'm not sure if that's it. Who knows? Okay, yes, the answer is this. We're looking for payments. We're looking for our missing payments. We don't know what are our missing payments. So this requires us to be a little bit more, exotic in the way we're going to look at this. Now, you know me by now, I love to do timelines. And that's exactly what we're going to do now. We're going to make a timeline to get a better sense of what's actually needed. Rosalie's already ahead of us. That's exactly it. And what we're going to do now is just to visualize what Rosalie put into the chat. We're going to put it within our timeline, and you're going to see that this only requires 2 steps from us, the answer to this problem. So now let's assume that we're going to start a timeline at the day our child was born, okay? Well, we know that there's nothing really important to see because our payments only begin at T6. So we're going to start our story at T6, so at year 6. Obviously, you could do this by saying that year 6 is year 0. Your timeline will only depend on how you want to go about it, but we're going to do it like this. It's a little bit easier to go through. So our kid is 6 years old here. T equals 7. We're going to go T equals 8. I'm going to skip a few years. We have T equals 16. T equals 17. And then. So
is the ultimate value or variable we're looking for the T6 PMT?
Well, that's correct. We're looking for the payment within those different years. So not at T6, but between T7 all the way to T17. Because in the question, they tell us, hey, we're going to make the same annual deposits up until year 17. So we're looking for that. That's the ultimate thing we're missing. Does that make sense?
So the payment is 0 at T6?
Yeah, because that's when our kid tells us that, hey, they want to go to Princeton. The question tells you that you start the next birthday. So that's obviously year 7.
Okay.
Perfect. So we have this, T equals 20. Then we have t equals 21. Cool. So we have our timeline. It looks good. Now we know that payments will be made starting the next birthday. So we understand that we have a payment here, a payment here, a payment here, and our last payment happens at year 17. Thing is, we don't know what those payments are. We have no clue what they are. Okay, so that's what we're seeking. But we still need to consider another element of this question. We also need to consider that we are going to make additional versements or additional payments to, we're making additional payments to the university starting year 18. What will be those payments that we're making to the university for year 18, 19, 20, and 21? What will be those payments? Guillaume says 30K, Charles says 30K. I think we're all on the same page. Yes, payments of 30 grand will be made each year to the uni. Okay, I'll put this in a different color just for it to be super clear. So we're going to pay the university 30K for 4 years because our kids actually going to be at school. All right. So let me just make this very clear. Payment to uni. All right. We're making 30K payments to the university for year 18, year 19, year 20, year 21. We're paying the tuition, right? The tuition. Now, let me just do one more step and I'll ask you a question right after that. So now we know that we have two segments to this question. All right. We have two different portions. We have the first portion right here where we're making deposits. We're making deposits to our bank account to be able to pay for university in the future. All right. So we could call this section A. Then we also have another section here to here where we're making payments to the university. Let's call this section B. Now, before we make that next step here, is what I want y'all to understand is that the premise of this question is the following. We want to understand how much money do we need to save every single year to be able to afford those payments, when our kid is older. So our goal here is that we want these two to be equal. So we want A to equal B, all right? We want the output of this to be equal to the present value of this. So we want FV 17 to be equal to the present value of those payments in the future to the university. So before we make that next step, are we all on the same page? Do we understand what we're doing? It's going to make more sense in 2 seconds, but do we understand what we're doing? So Guillaume has a good question. Are they dues? I'll answer that in a bit. But do we understand what we're trying to do here? We want our deposits to be equal to the payments that we're going to be able to make into the future to the university. Do other students understand this? Are we all okay with that? I see just one yes. If you have a question, just write it in the chat or raise your voice. I'd be more than happy to share.
I'm just confused about the 17 because they said it's until her 17th birthday. So
yeah, exactly.
I put the first 30K on T17 originally. That was like my intuition was telling me, but I don't know.
Okay, let me show you. Okay, so I think that's an amazing question because what we're telling you in the question here is that we know that the first tuition payment, right, will be payable on year 18, okay? So that's why using the timeline is really helpful because we know that a first payment has to be here, right? Does that make sense, Johan? Do you get that?
Okay, I fully did not read that. Okay.
Exactly, that's the thing, exactly. This question has a lot of stock. So that's why putting these different elements within your timeline makes sense because then we know that the next payment, the second one is at year 19.
Right.
And obviously the next two would be here.
Okay, cool.
And they tell you here that every payments are made till year 17. Okay. So that's something to consider. Now, Guillaume said an amazing question. And I want all of you to understand this. In a question, if they don't tell you that payments are at the beginning of the period, okay? Every question, if they don't tell you that payments are being done at the beginning of the period explicitly, then you're for sure dealing with a normal annuity. If they're not telling you that payments are done at the beginning of the period, you're for sure dealing with a normal annuity. Therefore, right now we're looking at this question and we're like, okay, we have fixed payments being done at a specific interval for a specific duration of time that we know. So in this case, this period of T7 to T17 has to be a normal annuity, right? So what we're seeing here is that we're dealing with, for section A, we're dealing with a, no pun intended, we're dealing with a normal annuity of T7 to T17. All right, so that's what we know. That's really good. Now, with that said, we know for section B is that we're dealing with our university tuition. That we must discount. To T to T18. Sorry about that. To T equals 17. So the first step, so the first payment is done at the end of year 6, or at the same time. By the way, another thing that I want y'all to understand is that if a payment is being done on your next birthday, so saying that something's being done on their next birthday is the same thing as saying that a payment is being done at the end of the year, right? So at year 7 in this case. So Pronto, that's a good question. In this case, they're telling you that it's on the next birthday, so it has to be at T7, okay? It has to be here, all right? Something really important to consider. So we're gonna go inversely here. We're gonna start with B. What we need to do is we need to find, well, what would be the present value of those university payments, right? What would be the present value of those university payments? Now to do this, all you have to do is the following, and it's as was that he said. All you have to do is you have to look at those university payments, all right? And you have to discount them at the discount, at the interest rate provided. Here, it's the account's paying 14%. And I'm gonna write this down and I'm gonna tell you why this makes sense in 2 seconds. So this is how you wanna go about it, to find the present value of those university payments. There we go. Okay. Now, I'm sure all of you are like, what the hell is he even doing? Why are we discounting these future university payments to find this present value of university payments? So what I'm going to say here, and this is going to be kind of meta, but it's really important and it's a good way to understand this. The reason why we're discounting these university payments for year 4, year 3, year 2, and year 1, so the 4th year of payments, the 3rd year of payments, and the 2nd and the 1st year of payments. The reason why we're doing this is because when you're looking at finance, you understand that discounting stuff and adding interest or compounding interest to stuff really is one and the same. The reason why we're discounting the 30K, this one at year 21 by 4, is because we know that technically, and I'll ask all of you if you understand this, we know that technically if we put payments, right, if we put our money in the bank at year 18, so 1, 2, at year 17, if we put money in the bank at year 17, right, we know that we could have interest on that money for 4 periods up until year 21 when we actually need to pay the university. So let me say this one more time. The reason why we're discounting 30 grand at 14% for T equals 21 is because we know that technically, if we were to put that same amount of money in the bank at year 17 and compounded interest up until year 21 where we need to pay the university, we would be able to actually not pay 30K upfront type of thing. So let me say this one more time. Instead of just paying 30 grand at year 21, you could decide to put money in the bank at year 17 and let that compound interest for 4 years to be able to have the amount needed to pay the university at year 21. So let me give you an example of what that means, just to be a little bit more concrete. So can somebody in the chat tell me what 30,000 divided by 1.14 is equal to? What is 30,000 divided by 1.14 to the power of 4? What is that equal to? What is our discounting of year 21 equal to? What is that equal to? We have 17,762.41. Thank you. There you go. Perfect. Okay, so that's what we find if we discount that amount. Now I'm going to ask y'all what this will be equal to as well. What is this equal to? 17,762.41 times 1.14 to the power of 4. What is that equal to? Gayor is giving a very smart educational guess. I don't know. Maybe that's the correct answer. I need 1 or 2 more people to tell me their answer. What is that? What is 17,762 to the power times 1.14 to the power of 4? So long story short, and I'm sorry this has been long on my end, but what I'm trying to say here, Rosalie, 20.9. What I'm trying to say here is that the reason why we're discounting these future university payments is because we're making the assumption that the parents could put money in the bank starting year 17 and kind of save that little 12K, right? They're saving $12,000 by putting their money in the bank today, rather than just giving them 30K upfront type of thing. So that's the idea here. That's what we're trying to accomplish, and that's why we're discounting these cash flows. All right. Does that make sense to everybody? Do we understand why we're discounting these cash flows now? Perfect. And Sarah, the reason why we're making this assumption is because we're assuming that every single human is a very intelligent and rational investor, that they will understand that they could put their money in the bank now rather than paying that same amount for like 4 years from now. That's why. So that said, now I'm going to ask you all to tell me what is 30,000 divided by 1.14 to the power of 1. So what is this? I'm going to need somebody to give me that answer. And then from there, it'll be really easy, I promise you. So PV 17. So 30K divided by 1.14 to the power of 1. What is that? Thank you. Thank you. Now the second one, what is 30,000 divided by 1.14 squared? What is that answer? Somebody other than Charles. So, I don't know, man. Charles, I can't read what you wrote. Is that 150,000 that you wrote? I don't know. It has to be somebody else. Has to be somebody else. Same as Charles. Perfect. Thank you, Simbi. So let's go with that. All right, and then somebody other than Charles and or Simbi can give me the answer for 30,000 divided by 1.14 cubed. Can somebody give me that answer? Somebody other than, you know what, I'll go with you. Sure, 100% Pronto. Good. That is the correct answer. And now anybody could tell me the sum of the present value of all these bad boys. What is the sum of all these different discounted cash flows? What is the sum of all these different discounted cash flows? Quelle est la réponse? Thank you. There you go. Okay. So now we have that. That's amazing. We have that portion. So we know exactly what our present value is right here. We know this. Now we need to make that equal to the future value of those payments. And that's future value 18. We need to find our future value of those payments. So what we'll need to do now, and this is fun. What we need to do now is very simple. We need to look at the normal annuity, right? We need to look at that. We want that to be equal to the present value of our university payments. So because we're dealing with a normal annuity and we're looking for its future value, we know that we could use the following formula. We know that we could use the following formula. All right. So before we begin, once again, you need to remember that we want the present value of our university payments to be equal to the future value of those annual deposits. Okay. So in other words, we want 87,411.37 to be equal to the following. All right, we need that to be equal to each other. Now, one thing to understand. Perfect. Okay, one thing to understand now is I'm going to ask y'all, what do you think our N is? What do you think our N is for this annuity formula here in this specific scenario? We're starting to put our payments in at year 17, but our last payment is at year 17. So year 7 to all the way to year 17. So what's our N? What's our N here? And we have Yohan that says 10. We have Rosalie that says 10. Charles says 11. Charles, why do you think it's 11? If you don't mind sharing your voice or writing in the chat. Why do you say it's 11? You could be very much correct. Pronto as well. Sarah says 10. So Pronto or Charles, do you want to share why you think it's 11, if you don't mind me asking?
Yeah.
Go for it. Yes. Why?
Sorry about the noise. So the reason why I put 11 is because you have to count year number 17 as well, including. So you do from 6 up until 7 including, that's 11 in total.
The idea here is that we have actually 11 effective payments being done, and that's why we have to put our N as 11. It's just something that you have to do. That being said, now what I'm going to ask y'all, and we're going to take a little break. We go grab some water and a little snack after this, just so I can have the same energy for all of you. Now I'm going to ask you, if we put all those different elements, and I'm not going to give it to you, I'm going to ask you to really, write it down on paper. What would be our payment? We understand that our missing value here is payment. What would be payment in this case? If we already know, we already know this, and we know this. We're only missing payment. What would that be? I'm not going to write down the things to put down into the formula. I really want y'all to try it out. So what would be our payment? What are those annual deposits that we've been talking about for so long now? What are our payments? What are our payments? What is that all about? No, I mean, like, what's this, right? Because we're only missing this. We have this and we have this, right? We're trying to equate our future value of those annual deposits to the present value of our university like tuition payments. So Devon says an interesting number. Maybe that's true. Maybe. And just for ambiance, what's the answer? Devon says 3,793.15. It's $1 million is on the line right now before our break. I need 2 more answers. Is Devon correct? You guys could call a friend or ask the audience. But yes, the answer here is definitely the one given by Devon and Charles and so forth. So that would be our payments here. All right, that would be our payments here. So the reason why our N is as follows, it's the following idea here, right? We're starting our payments on her next birthday, and we are making a payment also on year 17. So you have to compute for every single one of those payments. You could literally use your hands and you'll find that they're making actually 11 payments rather than just 10. And that's why, Devon, that our N is equal to 11. Oh, did I make a mistake? I could have made one. I could have given you guys the wrong formula though, I'm not gonna lie. Give me a second, I'll check it out. I could be slightly wrong.
I might be mistaken too. I just want to probably explain it verbally, might be clearer, because I was going through the formula sheet.
Yeah.
And because the formula used here, shouldn't it be PV instead of FV?
You guys are correct, sorry.
Okay.
That the answer is still the same, like yes.
Okay.
The correct formula, I'm sorry, I wrote the wrong one. Sorry about that, everybody. It's going to be the following, okay? So it's going to be future value at N is equal to payment, right? Times the following for a normal annuity with definite payments. Sorry about that. So it's going to be this. Yeah, sorry, that is the formula that you have to use. I'm totally sorry. I gave you the one for the present value on some tired thing. Sorry. So yeah, the future value for a normal annuity, and if you go through the formula sheet, yes, indeed, is going to be equal to payment, right? So times 1 plus k to the power of n minus 1 over k. That is the correct formula. You are all totally correct. Thank you for that. So this right here is not what you want to use. Yes, Devon.
Yeah, so just to clarify, it's N is 11 because we're going from 7 to 17, but then from 17 to 18, we're paying again.
Well, how it's going to work, and let me check if I'm wrong. So you have 7 years, 8 years, 9 years, 10 years, 11 years, 12, 13, 14, 15, 16, 17, right? So you're making a payment at every single one of those years.
Oh, okay, I get it. Okay.
That's why, and I'll do it once again. So the reason why we add N as 11, and that's honestly, I use that trick to this day, and I'm graduating. I just look, okay, so we're making a payment at T7, so at year 7. So year 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, we have 10 payments, 17, right? Every single one of those years we made a payment. So we have 11 payments being done. Therefore, N is equal to the number of payments being done. So yeah.
Okay. And what was that? You said it earlier. If something isn't mentioned, then we assume normal annuity.
Yes, exactly. So if nothing in the question so if there's nothing in the question that says a payment is being done at the beginning of a period, you're dealing with a normal annuity. The only scenario in which you think, okay, I'm going to use an annuity due formula is when it tells you that payments are being done at the beginning of the period. If they're not telling you that, then you must consider that you're using a normal annuity formula, which is the one that you see on the screen right now. Charles says, actually, I did this prompting part. It was an annuity. Yeah, so the reason why, Charles, you got that answer is because technically annuity due is the same formula as in a normal annuity, but you just add one compounding period. So you probably put your N as 10, but you did 1 plus K at the end, and that's why you had the same answer, right? So it's the same thing. That's kind of more involved, but yes, Charles, that's exactly why you had the same answer. But that's okay. And then Tamara says, can you explain why are we finding the future value for it? So the reason why we're doing this is because, and I guess I'll use something that's a little bit cleaner. We'll go here. So you have this timeline, right? And we know that we're making payments, right? Typically, when you're making payments every single period or at a certain frequency is because you want to have a bigger amount in the future, right? That bigger amount in the future, in very simple terms, is what we call the future value. So we know that we are making all these annual payments for that to be equal to the present value of those university payments we're going to make in the future. So already we know that it's impossible that we're going to look at the present value. We only want to look for that bigger amount. right? We want to look at those annual deposits to get that bigger amount. Therefore, we could only look at the future value formula for a normal annuity. And that's why we're finding the future value, because we want the sum of those payments that are being compounded at a 14% interest rate to be equal to the present value of those university payments that we'll be making into the future. That's why. So before we take a little breather, before we take a little break, I'm going to ask everybody here, are we okay with this? Did this make sense? This is like as hard as a TVM question could be. There's maybe another type of question that could be a little bit like in the same vein, but this is really as hard as it gets. So no, so it's Tamara, it's the way it is that the future value of our annual deposits is equal to the present value of our university payments. This is the present value. What we did here is to find the present value, right? So once again, the present value of our university payments is equal to the future value of our annual deposits before our child goes to school. And Pranto, this would be like this. There's only one other question that's equal to this level of difficulty, and it's literally like this is as hard as it gets, really, when it comes to TVM. And Gayor, the reason why it gave you the same answer. Let me show you. Let me show you. You mean like, do you mean which formula do you mean? Just to be sure, Gayor. Just to be sure.
Like in the bottom, the one that you crossed out.
Yeah. This does not give you the same answer at all. This is just me capping. It's this is no way. This is incorrect.
Okay. So whoever gave you the answer did it the right way.
Yeah, exactly.
Okay, cool. Thank you. That's right. Thank you.
Yeah, that's exactly it though. So the hardest part of these questions is just breaking it down. The math of it is very simple. It's just breaking down the question into like a normal bite-sized bit. And that's honestly all it takes. So with that said, I'm gonna go get a little bit of food. So let's take a, let's call it a 7-minute break. So at 7:40, let's come back and we're gonna continue going through practice problems together and really making sense of it as we go. So let's take a 7-minute break. We'll get back at 7:40 and we'll get this show on the road. Alrighty. All right, let's get this show back on the road. And yes, Charles, I do like me some jazz. I'm not gonna lie. Gets you to be calm and stuff. You know, it's the good stuff. It's the good stuff. So yeah, that said, let's check out number 4. Number 4, another time value of money question. Super easy. Literally, it's a free point. And you'd be surprised that I saw this on my final exam. And I was like, all right, give me the free 4%. That's not a problem. I'll take it with a smile. So pretty funny that they've added that. So yeah, that said, let's give it a shot. This question, the involved solution is in the course pack if you go up, but you know, it's not as complicated. So I'm going to spend more time talking when it comes to this question. That said, so when it comes to this question, we have Jake. We have Jake, and Jake is going to put $698.45 in an account which pays 29% compounded annually. And we're asking you, how much more additional interest can he earn over 4 years if he moved his money to an account which pays 30% compounded annually? So when we see this question, we just need to be able to identify really a few pieces of this puzzle, because we know we have this amount right here. This amount, we could call it our present value. And we know that at first, we're going to compound it annually at 29%, such that we could call IY, our first IY, we call it IY1, is equal to 29%. Now we're asking you, how much more additional interest? More additional interest. That sounds like a lot of words to say something very simple. In other words, we're asking you, how much more money will you be making? How much more money will you be making, right? Over 4 years, 4 years being your N. So N equals 4. If you moved your account or your money within an account that pays 30%, right? That meaning that IY2 is equal to 30%. Okay, so in order to answer this question, it's really a simple game. It's as simple as doing the following by saying, well, what would happen if, what would be our future value for B minus future value for A? That's going to be our additional interest. Right? This is a scenario for B where we have 30%. And this is the scenario where we have 29%. So the dynamics are very simple. In order to find the answer for this question, all you have to do is use a financial calculator and plug in the different inputs provided to you for scenario B and for scenario A. Once you have the future value for both scenarios, you'll be able to find the total difference in terms of interest. All right. So what I'll do is I'll kind of lay out scenario A and scenario B. We're going to find their future value, and then we're going to look at the difference between the two. So let's look at scenario A. When we're looking at scenario A, I'm going to ask you for every single input to tell me what you think the answer is. So what is n for scenario A? Actually, let's write it for scenario B as well. What is n for scenario A? At the same time, I guess we could say, what is n for scenario B? So what are n's? Okay, cool. I think we could all agree that our n will be the same in both scenarios. What is our payment? Do we have a payment for both scenarios? What will our payment be equal to? Devon says 0. Maybe, I don't know. What is the answer? Charles says 0. Yes, the answer here is 0. There are no payments. In a question, what is a payment? A payment is a specific amount or a growing amount being done at a specific interval of time for a definite or indefinite period. In this case, we don't have that. In this case, we're just starting with one specific amount and that's it. So what is our IY? What is our IY for A and what is our IY for B? I think this is literally the premise of the question. What is our interest rate for A and what is our interest rate for B? When I say IY, it's the input that you'll have in your calculator. Thank you, Charles. 29 and 30. That said, now, what is our PV for both scenarios? I'm just doing this because these are the inputs that you'll have to add into your calculator. It's very simple. Perfect. Cool. Now, this is something that you may not have to change if you haven't looked into mortgages, but just make sure to make the following always equal to 1 when you're doing these types of questions. So set CY, so your compounding periods per year as 1, and your payments frequency per year as 1. So put these two at 1. Just for context, C over Y or CY literally means compounding periods per year. And then P over Y, or as I say, PY, means payment per year. So if you're compounding annually, the number of compounding periods per year is equal to 1. If you are making payments annually, the payments per year, in other words, PY, is equal to 1. So now we have all the good stuff. We have all that we need. Literally, you do not need any more, inputs here, except for the following. You're going to need to do this. You're going to have to compute for the future value. We're going to have to do the same for scenario B and scenario A and B. So what is the future value for A? And what is the future value for B? Somebody tell me, with all these inputs, what are the values? So we have Devon is giving us a good answer. Good. And then future value for B, we have Charles. Thank you. Good. All right, so now I need somebody other than Devon and Charles to tell me what would be the difference of future value B minus future value A. What would be the difference? So Jan says exactly 60.67. So that's the answer. It's as easy as that. It's really, really simple. It's really simple. 60.67. It's as easy as that. Perfect. So that said, I think, do we have any questions here? Is this straightforward? Are we okay with this? Perfect.
Do you think it's probable we'll get a question like that?
Honestly, it's probable. Like there's a probability, probably like 20%. But the idea here is that you just want to be prepared for this because you may see this on your final. And you also may see it on Saturday. So just knowing that you could go through it is just something that's, good.
I just feel like they're going to give us such hard questions because there's only 15. It's unlikely that, you know, there's like an easy, like a give me question.
You'd be surprised. You'd be surprised. You'd really be surprised. It's like literally a surprise type of thing. So, and people fail all the time. Like in my semester, I think the average was 37%. And you'd be surprised that some of the questions that we did today that you guys were like, yeah, that's easy. You know, we'd be happy to see that, were the questions that people were messing up. So it's really, you know, the idea here is that you want to be as prepared as possible. June randomly retired. That's hilarious. Maybe, yeah, maybe. But I think you'll be fine. Okay, perfect. Okay, so that said, let's check it out for the second question. Not the question, the fifth question, or second question that we're back. And this one relates to equity valuation. Equity valuation is honestly not the worst, but it definitely does require you to kind of apply some sort of thinking. And this one's fun because you get to look at a bunch of different formulas to do so. It's like it requires you to be versatile. So that said, what we're going to do is we're going to go through this question together and we're going to identify the different parts. So we're discussing this idea of preferred shares, all right? Preferred shares are something that you really don't spend too much time looking at in class, but it's definitely something super important to look at. And as you know by now, with me, as soon as I see, yeah, exactly. Equity valuation is like, they don't spend enough time on that. But I think if we apply the same protocol and we apply the same frameworks that we've been doing, this will really, really, really help you to do well, okay? So when you see preferred shares, and with any other question, you want to be able to identify the different formulas you could use to solve any type of question related to this topic. So when we're looking at preferred shares, we're looking at two formulas. So why not kind of just put them on the corner somewhere and have them, you know, as a point of reference. So when you're looking at preferred shares, you may have one of the following. So call it preferred shares. You may have a formula as follows. You may have the PS over KPS. So what does this mean? Essentially, this means that we're able to find the following. So we're going to have our preferred shares is equal to the preferred shares value, by the way, value. So how much it's worth is going to be equal to the dividends to preferred shareholders over K, right? K being the required rate of return, right? K being the required rate of return. It's good to know that you have this formula available to you because you never know when you may need to use it, okay? Now, there's another formula that we could refer to when we're looking at preferred shares, and that's literally the formula to find the preferred dividends. So the dividends paid to preferred shareholders. And it's a really, really, really simple formula. All that you have to do is as follows. So dividend payments is equal to the following. All you have to do is take the dividend rate times the par value of the preferred share. Essentially, the face value. All right. So just like that, we have a few formulas that we can use, you know, to solve this question. We didn't even start solving yet, but now we know that, okay, maybe we could use that to at least have a sense of direction, have it as a North Star for a problem, okay? And if you look at the problem, it already tells you preferred shares of light electrical company have a par value of $100. So already there, you know that preferred share has a par value of $1,000. So that's cool. We know that. Amazing. And then it tells you that it has a dividend rate of 8%. Look at that. Our formulas are helping us out. Now we already know that we'll be able to find our dividend payment. And once again, it's obviously that this question is made for you to use these different formulas. But just like that, by reading the question and by understanding that you have the specific formula related to preferred shares, you're able to find a different part of a formula needed, right? Because if you have your dividend payment to preferred shareholders, then obviously you have the following, right? So just for fun, I'm going to ask you, what would be our dividends to preferred shareholders, knowing that our par value is $100 and our dividend rate is 8%? Just for fun. We don't know where we're going with this, but we're moving forward step by step. So Charles says $8. Is it $8? I mean, I don't know. Only one person answered, so I can't tell you yet. Is it $8? Sarah says $8. Yeah, so the answer here is $8. The reason why it's $8 is because you take $100 multiplied by 8%. And that's going to give you $8. Simple like that. That's all you need. So now we have one bit of information. And amazing, they're also telling you, hey, the current price of that specific preferred shares is equal to 105. Okay, so now we know that the value of those preferred shares, the market value, is equal to 105. So if we look at this formula, we now know that we have 105 is equal to $8 over K. Can somebody tell me what's K? I mean, we're there, might as well. Step by step type of thing. So we have 105. We know that's the preferred shares market value. And we also know that we have this formula right here that uses the following. No, the risk-free rate is not the same thing as the required rate of return. The risk-free rate is literally a rate of return that you know you could get no matter what. So let's say you invest in the government or a government bond, or you just leave your money in like a very specific mutual fund, you'll be able to get the risk-free rate. The required rate of return is very subjective to a certain sense, but that we'll look at for exam 2. I'll spend a lot more time on that. But now my point being is that we have this formula and we have this. All that we're missing is K. And I'm saying that because we know that when we're looking at preferred shares in equity valuation, so chapter 7, we know there are 2 formulas that we could use. So why not kind of like try to attach or match our different elements that we have from the question and find the missing pieces of our puzzle. So Sarah says that our K is equal to 7.52, 62. Maybe she's correct. Maybe she's wrong. I don't know. I need 1 or 2 more people to give me an answer, right? What would be our K here? What would be our K? Devon says same. Yes, exactly. So we have the following. Now, this is really cool because now we have a little bit, we have some information available to us, which we didn't really have at first, or at least it didn't seem like it. All right. And then the question tells us that if the risk-free rate is equal to 2.5%, what is the risk premium associated with these preferred shares? Now, I'm not going to lie. Pronto says I still didn't get where we got it from the 762. How come it's 7.62? Well, check this out. So we have our preferred shares formula, which is equal to div payment to preferred shareholders. And we could do that over K. All right. Now we know that our preferred shares market value is equal to $105. And we know that our dividend payments are equal to $8, such that our only missing variable is K. Now, before I go to the next step, yeah, so we all Yes, Devon, you'll be able to look at the recording. Exactly. Exactly. Just because we're looking for the missing part. So that said, if we divide 105 by 8, we get 7.62%. Or 8 divided by 105, sorry. So we have k is equal to 7.62. Now the question is asking about this idea of the risk premium. Now, what is a risk premium? I'm not gonna lie, the first time I heard about the risk premium, I was like, what the hell are we talking about? We don't really have that formula laying around. And if your teacher doesn't do a good job and kind of talks about it, or if you didn't read, 5 chapters ahead for exam 3, you wouldn't really necessarily know what it is, So it's a really simple formula. The risk premium, and we're going to look at this a lot in exam 2, but just for this exam, if they ask you something like that, the risk premium is equal to the following. It's equal to the risk-free rate. No, actually, let's do this. It's equal to K minus the risk-free rate. Such that, yes, of course, risk in the market. So, well, you don't really have to look at it as deep as that. And this is like a more involved concept. But the way you want to look at it is that, let's think about this. All right, let's all take 2 seconds. All right, let's say that we're all trying to make some money. All right, we all have $100 to spend. We all have $100 to invest. Okay, we all have $100 to invest. Right now, we could go to our parents and they could give us 2% on our money at the end of the month. How much money would we have at the end of the month if we take our 2%? We could go to our parents, we invest our money into our parents because they want a loan, and they're going to give us 2%. How much money do we have at the end of the month? We have $2, okay? So we have $2 plus our initial amount. So we have $102, all right? But then you could go and give your money to your big brother. But your big brother is a little crazy sometimes. And he's like, listen, I have this crazy idea to build magic candles that takes out a genie out of nowhere. It sounds interesting. And he's telling you, just give me $100. I promise it's going to happen. And I'll give you 20%. All right. But, you may lose the money because I don't really have a product yet. It's kind of magic. All right. So he's selling you 20%. Now, let's say that it actually works out. How much money do you have at the end? How much money do you get? Let's say it does work out. Yeah. You have $20. So you have $120. Now, can somebody tell me what's the riskier investment? Is it your parents or your brother? Just in terms of logic, where would you rather put your money in? Into your crazy brother with the crazy magic candles, or your parents who are going to for sure give you your money back at the end of the month or at the end of whatever period? So Gior says your parents. Sarah says your parents. Rosali, what do you think? Just for fun. You're going to see why this makes sense, although my example really bizarre. So who would you rather give your money to? Parents. Rosali, what do you think? Parents. Okay. Sorry?
Could you just repeat the question, please?
Yeah, I was like, okay, let's say your parents are going to give you 2% on your money, but it's guaranteed to come in, and your brother may give you 20% if and only if his business works out. But remember, his business is about magic candles that summon a genie, like in Yu-Gi-Oh! Where would you rather put your money in? Parents, exactly. So some may call this a risk-free investment, because you're guaranteed at 100% you're going to get your money back, unless your parents, I don't know, like something terrible and God forbid happens. But your brother That's a risky investment. You're not sure that he may just run away with your $100, or he might just fail. So the idea is that the risk premium is how much more money, how much more percent of return you'll make vis-a-vis the risk-free and the risky investment. Obviously, between the two, there's an $18 difference. That's what we call our risk premium. To take on the burden of having more risk, to make a weirder investment, a riskier investment, as an investor, you should be compensated for that. Taking on more risk versus the stuff that's guaranteed should yield more money for it to be worth it to you, right? So that's why the risk premium is equal to K minus the risk-free rate, because you're comparing your investment that you're making you're comparing your investment in comparison to the guaranteed asset, the guaranteed investment. That's why you do take your required rate of return minus the risk-free rate. So in this case, $120 minus 102. That's the idea. So that said, sorry about that. That's mute. Okay. That said, what would be our risk premium in the actual question, where we have 7.62 minus 2.5%? Yeah, exactly. How much more money? And within finance, we really look at how much more returns. Like, what's your expected return difference? We look at percentages, but technically percentages could be money at the same time. But you know how people like to be, they like to complicate things. But yeah, so what would be our risk premium for this question? We have our required rate of return that's equal to 7.62%, and we have our risk-free rate that's equal to 2.5%. Yeah, so the answer is 5.12. So that's how you want to go about it. Now, before we proceed, was this okay? Are we all right with this? Can we all breathe if we see this on the exam? The first step is to look at similar formulas, identify what's within our prompt, and then match that to the formula, and then just solve for the missing parts. Exactly. That's exactly what you need. Every single question, you need to look at what are the associated formulas. Then what do I have within the question that I could plug in? Then you just solve for the missing variables. Sometimes you may use a timeline. That's the only distinction. Okay. Okay, more dividends. Jeez. All right. I'm with it. Does this make sense? Did I? Okay, so we have Planner Corp. Planner Corp. Cool. So let's check it out. Thank you. So let's check it out. So we have Planner Corp. This is an equity valuation question once again. It's a little bit one of those trickier ones. I don't think you'll see something as involved as this one on your exam, but it's really, really interesting no matter what, nonetheless. So let me just check that out for y'all. Just trying to pop out my solution bank from my computer for this specific question. I don't always do it. So that said, what we want to do now is that we know we have Planner Corp, which pays a $2 dividend year to year. It's pretty cool every other year. Oh, it's not popping out. Give me a sec. Give me a second. I'm trying to find my solution bank here. Okay, whatever. Anyways, so yeah, we have Planner Corp, which pays a $2 dividend per share that you own every other year. And their most recent dividend was paid today. Now we're telling you that 5 years from now, the company will repurchase all of the outstanding shares at $50 per share. Now we're asking you, what is the stock worth today at an 8% rate? Now these questions are really, really fun because they require you to kind of get a little bit more exotic with the perspective. We're mixing TVM with equity valuation formulas. It gets really interesting. All right. So that said, what we do know is that we have a $2 share, $2 per share. Whoops, $2 a share. So you said $50. Yeah, so the point is that you know for a fact you're gonna get $50 at the end. And that's a really good validity. You'll see why that matters. So you know that this is happening every other year, that the company will pay you a dividend. And you know that their most recent dividend was done today. Now you know that 5 years from now, they're gonna give you $50 because they're gonna repurchase your shares. Now we're asking you, well, what would be the worth of that stock today, knowing all these different pieces of information at an 8% rate of return? So the first thing that I really want all of you to understand is that when we're looking at dividends, when we're looking at equity valuation question, and this is super crucial. When we're looking at equity valuation questions, if they tell you that a dividend was paid today, that means that we're looking at the following. We're looking at D0, all right? If a dividend was paid today, that means that we're looking at D0. If we're telling you that a dividend is being paid at the end of the year or next year, we're looking at D1. So what does this mean for us? And what is a commonality here? This is exactly the same perspective that we apply to annuities when we're looking at time value of money questions for chapter 5. So that same idea is being applied. So if a dividend is being paid today, that means that that's equal to the timeline year 0, T0, D0, however you want to call it. Okay, so that's really something to understand. Now, with that said, let's look at something really, really, really simple. Let's look at the timeline. That's the first thing to do when you have a question like this. And this really does resemble to a time value of money question. So let's do it like that. So we could write T0 or D0. They honestly all mean the same thing. It's really up to you, but we'll write both for good measure, right? Now, the reason why we're looking at 5 periods, i.e. 5 years, because we're looking at this question here, the reason why I'm doing so is because obviously the question tells you 5 years. So why look at more than that or less? This is what we're going to look at. So now, the first bit that we want to check is that, okay, well, we know that payments are being done every other year, and we know that the first payment actually began here. In other words, the payment already kind of passed. Like the payment happened today, and if you bought this the stock tomorrow, well, you wouldn't get that dividend, right? Just something to consider. But we know that the first dividend payment was done today, all right? It kind of passed. So that said, when would be our next dividend payment? Will it be done at T1, T2, T3? When will it be? All right, nice. So here we don't have a payment. Here we do have a payment, right, of $2. We don't have a payment here either, but we do have a payment here of $2. Do we have a payment at year 5 other than the $50, just for fun? Do we have a payment at year 5? The answer is no. Good. So we don't have a payment, but do we have something at year 5? Is there something that I forgot? Do we have something at year 5? Like, do we have something at year 5? Yes, yours says $50 because of the repurchase. Okay, so Rosalie, the reason why is because this question tells us that Planner Corp will pay a $2 a share dividend every other year. So because the first payment was done today at D0, that means that next year there shouldn't be any payments. There should be a payment at D2 and then no payments at D3, then a payment at D4 and no payments at D5. But why? Because the question says every other year. the company pays a dividend every other year. So it's like me, I tell you, oh, no. Well, I mean, that's one thing with Comp 308. Well, with finance questions at JMSB, is that some questions really do rely on the verbiage, right? On the way they write the stuff. And some people, like myself too, when I first did this question, I was like, okay, well, every next year, right? Every other year, they're going to pay more money. But in this question, they literally mean like every other year. Like you skip one, then the other year you pay. You skip one, then the other year you pay. It's really one of those stupid verbiage questions. It's something that as you do more questions with Comp 308, the more you realize, okay, that's the way they want us to understand. But this is an amazing point to share. One thing and an extremely good skill to have, and I say this all the time, when you study for a course, when you study for an exam, you need to study relative to the people that are testing you. You know, if you took this exam at another place or at another school, the way they would ask you the question would be 100% different. But now you're at JMSB. Now you're taking Comp 308. You need to look for the commonalities in the way teachers and the way the course is asking you questions. If they ask you questions in the most nonsensical, stupid way, you have to get used to that. You have to get accustomed to that idea. Any other, that's an amazing question. I really do think that if they don't tell you that a payment is being done at the beginning of the year, then you know you're dealing with a normal annuity. Another thing to understand is always look for if the interest rate given to you is annual or not. If they don't say anything, then you need to assume it's annual based on the context, right? Because in this case, we're looking at years. But sometimes we're looking at periods of 3 years, and they're giving you an annual rate. You need to be able to associate that. You need to find the effective rate. But other than that, I mean, it's typically with the other year thing. Like for exam 2, if you guys want to work with me for that, is that they do talk about that a little bit. And then Yuan says, yes, so a Canadian mortgage versus an American mortgage. A Canadian mortgage, if you see that, you need to know that it's 2 compounding periods per year, like C over Y equals 2. But if it's an American mortgage, it's equal to 1. So that's another thing to understand. They won't mention that unless you really go through every single slide. So that's why it's important to understand that. Yuan, that's an amazing point. Canadian mortgages, your compounding periods are equal to 2. American or whatever other mortgages are equal to 1, the compounding periods. So it's just something to consider. Free points if you see that on your exam. It's kind of like those improbable things, but if you do, it's a free point. So yeah, 100%. The verbiage is, the vocabulary things are always a little bit stupid on their end. So with that said, now we know that we have the following cash flows that we're expecting up until year 5, up until the repurchase, right? We're expecting the following cash flows. So we're expecting a cash flow at T2, we're expecting a cash flow at T4, and we're expecting a cash flow at T5. So with something that we've done, even with the university tuition payments, is that in order to find the value of something today, all that we have to do is discount its future cash flows, right? To find the value of an equity or an asset or whatever, all you got to do is discount them to find the present value. So discounted value of the future cash flows. So the present value of this dividend, will be equal to the following. And I'm going to be really funny with this. So we have 0.8% to the power of 1. And I'm going to test you guys right now. Do I have to put something here? Is it $2, $0, $5, $50? What's my numerator here? This is just me testing you. What is my numerator here? At the power of 1. Ah, exactly. This is just me testing you. Because we have no payments at year 1, obviously we're going to discount $0, nothing, right? There's nothing to discount. Really important to remember. This is just a trick. It's going to be really helpful for you when you go deeper into, finance courses or comm courses. This is something to understand, especially when you build models, okay? So no payment. Anyways, that said, what about year
Good
2?
question.
What's up?
For T0,
Yes,
the exponent in the denominator would be 0,
exactly.
but wouldn't that make your whole thing equal to 2?
Well, that's an amazing point. And yes, because if your exponent is equal to 0, then your denominator is going to be 1. But the thing is, in finance, if a payment or whatever was done at year 0 and it's not an annuity due, those monies are not considered. It's like it doesn't occur. And to go even deeper, to really make it like something that you could remember and understand forever, is that let's say we all want to buy Apple today. Okay. We all want to buy Apple and Apple stock. The thing is, we know that Apple today, February 16th, has issued a dividend of $2 per share. Okay. So obviously the people that owned it today, you know, in the morning when it was issued, are going to receive $2. I think we could all agree to that per share. But let's say we buy it at night. Like, let's say we buy it right now. Are we still going to get that dividend if it was already issued in the morning? Yes or no? Are we going to get that dividend if it was exactly? The answer is no, because that dividend was already issued. And to go even deeper than that, by law, by the SEC and NASDAQ, whatever, by law, a dividend is going to be committed to the shareholder, the owner, 3 days before the actual dividend like payment. It's called an ex-dividend date. It's something that you don't need to know. This is like way deeper into your major if you do finance. But the idea is that it's already committed no matter what. So the idea here is that if something is actually distributed today, there's no way in hell, even if we buy it, that we're going to get that dividend. So that's why we don't consider it as a cash flow. That's why we're not discounting it. So that's like the real reason why. But the simple term is that, hey, if it's at T0, we don't look at it because we're not going to get it. Okay. Simple as that. That said, so yeah, for year 2, sorry, we have $2. What will be our exponent here? What's our exponent? And Sarah, yeah, if it was an annuity due, we would count it 100%. Yes, Charles. I think we understand the vibes at this point. So I'm gonna expedite the process. Now this one is fun. What about year 5? What about year 5? What is our exponent at year? I mean, what is our numerator at year 5? Is it $50 or is it $2? Rosalie, that's the best answer actually. 0 plus 50. Exactly. That's good because we're getting no dividend payment, or we're getting a repurchase. That's a good answer. That's 50. Okay, cool. So now I'm gonna ask y'all to give me the individual values for each, one by one. So what about year 1? What is our answer there? If we do year 1, 0 over 1.08. Nice. What about year 2? What about year 2? Nice. What about year 3? What about year 3? What is our value at year 3? Right here. What is our value here? Nice. What about year 4? What is our value at year 4? What's a discounted cash flow at year 4? Nice. Thank you. Amazing. And then what about year 5? What is that large sum? Exactly. Now, if we sum up all these different cash flows, all these different discounted cash flows, what is that equal to? I need one more person to give me that answer. Une autre personne. There you go. Amazing. So that's the answer. Do we have any questions? Does this make sense to us? Or we could proceed. Okay, good. Good. We got another 36 minutes. Let's try to bang out 1 or 2 more hard questions. The good stuff. The next one, it's a personal favorite. It's a classic. You know, I've seen it 3 times within my what, a year, or call it 2 years of seeing this. And it's the good stuff. It's the good stuff, and thankfully there's a really simple explanation to have here. Something that makes this easier for you. So you're gonna love the explanation here. Let me just find something for y'all. Let me find a step by step. Now, for this question, I'm definitely gonna recommend all of you to definitely go through the course pack. In the course pack, I spent like an hour breaking down this question into like bite-sized pieces, just for you to really have that like extra layer of content when it comes to this question. Then there's also a YouTube video on this one, really for me to cover all the different angles. Okay, so you're gonna have the recording, you're gonna have the YouTube video, and you're gonna have the course pack notes. Plus, there's another type of question just like this in the course pack. You're gonna have 4 different ways to make sure you understand this. This was in the final last semester, and this was in the first midterm last semester. Then this was in one of my midterms back in my time. So this is a very possible question to have. And the different pieces within this question are literally skills that you need to know regardless, and that may actually occur in different questions that you may have. So no matter what, this is like a must know, this is a must understand type of thing. Okay, so let's get it started. This is a really cool one. So the present value at t equals 0 of the following cash flow, okay, is $1,262.23. All right. So we know that this is the present value. All right. And we know that this is going to be discounted at 12%. Okay. Every year. So the effective annual rate is equal to 12%. All right. So this set of cash flows discounted at 12% gives you 1,262. All right. 0.23. At the same time, if we're telling you that if something is being discounted at a rate, it also means that we could apply interest. Okay. We could compound interest at that rate. So we could go backwards, but we could also go forwards. So this is just our interest rate, i.e. this is our K per year. All right, this is really important. Now, this question's funny because it gives you these 2 bits of information, then it stops. It tells you, well, what is the value of the missing cash flow? All right, what is the value of X? X being these bad boys. All right, what is the value of X? All right. All right. So assume the pattern of these payments are being done in perpetuity. Assume these payments, okay, are going to continue in perpetuity. So can somebody in the chat or by voice tell me what the hell does that even mean for these payments to happen in perpetuity? I want somebody to give it a shot, either by voice or by chat, really as you will. What does this mean?
Goes forever.
Okay, and like, can you give me like an example? Like what would be maybe like T10, T11, T12, and so forth, if you'd have to take a guess?
Infinity.
Well, what would be the cash flow at
Oh, okay.
T10? What would be the number? Like what would be here? Okay, so Yusra says 100 for T10. Nice. Okay. T11, therefore, would be, as Charles said, X. And T12 would be 2X. So what I'm trying to say here is that we have a pattern, right? Can we all agree that there seems to be a pattern here. That's occurring like this, such that there's going to be a pattern like this forever. Okay, cool. So the idea here is that there is a pattern that's going to continue to occur. Well, it seems like every 3 years, right? Every 3 years, there's going to be 100x 2x, 100x 2x. So that's what we mean by something that continues in perpetuity. This set of cash flows will. And I mean, this helps you, and then this helps you to understand that as well. Like it kind of screams at you a little bit once you understand that that's what we're looking for. Okay, so that's cool. That's the first thing that we understand. So now we know that 100% that we've identified that we're dealing with a perpetuity. What I like to do when I have a question is I like to identify, well, okay, if I know I'm dealing with a perpetuity, well, then what are the different formulas that we could use here? And it turns out that with perpetuities, there's one single formula that we could use if it's not a growing perpetuity. So what is that formula? Can somebody write it in the chat? What is that formula that we use now that we know we have a perpetuity? What is it? It's very easy. It takes like 3. There you go. There you go. Thank you, Gayor. That's exactly it. No, well, actually, no, you're missing one part. There's one little element that you need to take off. When we're looking at a perpetuity, there you go, Charles. Yes, exactly. It's not 1 plus K, it's just K. It's payment over K. All right, so it's not 1 plus K. 1 plus K would not be a good representation. It's K because we want to extrapolate the number. Yeah, it's pretty cool. But yeah, so essentially, we know that now there's only one formula that we could potentially use, right? It's present value equals payment over K. So we only need to look at a few things here because we know what's our present value. Like we understand that. We know that our present value is going to be equal to the following. We have an idea of what this could be, and we have an idea of what this could be. Now, our duty for the remainder of this question is to deal with that actively, to figure out how we could do so. Okay, so the first step that we're going to do is we're going to look at payment, then we're going to look at our K. And from that, we're going to be able to find our answer. Okay, so when you see a question like this, when we're looking for our payment, the thing that we're going to put as our numerator, we need to look at it from this perspective. Okay, and I'm going to tell you straight up. Our payment is going to be equal to this reoccurring box. Okay, our payment will be equal to this reoccurring box. Why is that? Well, let me just kind of continue with this to make it super clear. We're going to group this pattern that's happening again and again as one large payment, as one big payment. Okay, let me say this one more time. We're going to group this pattern 100x 2x as one big payment. Alrighty, so we're going to have a payment like this, a payment like this, and have a payment like this. Now, I'm sure to some this makes sense, but I'm just going to go, one step further. So let's say that you have some really cool parents, and they're like, you know what? Call it every September, every October, and every November. Essentially, they're saying at T1, T2, and T3, we're going to give you different cash. We're going to give you different cash flows type of thing. All right. So they're telling you that, hey, on T1, we're going to give you $100, and on T2, we're going to give you $200, and on T3, we're going to give you $400. Okay. The idea is that, and I can even make it better. They're going to say on Christmas, we're going to give you money. On your birthday, we're going to give you some money. And on Valentine's Day, we're going to give you some money. Okay. All right. So we're going to say this is your B day. This is Valentine's Day. And this is Xmas. This is going to happen forever. Your parents really love you. Okay. So they're telling you that every time we're going to do this. So now I'm telling you guys, if we know we're going to make $100 on our birthday, $200 on Valentine's Day, and $400 on Xmas, I mean, can we just say that within those 3 dates, total, we're going to have $700? Does that make sense? Can we do that? Yeah, we're just, instead of looking at every single date, we're going to group all those different payments as one, right? We know that every year we're going to make $700. Now in the question, we're not looking at, periods within a year. We're looking at just specific one by one years, but still, this is just an example. So let me say this one more time. Does it make sense that we group these cash flows because we know they're reoccurring as one bigger payment? Does that make sense? I need to see everybody say yes, that we could group them as one. Cool, amazing. Okay, so we have that. That's the beautiful part. That's cool. We got that out of the way. So now we know that we need to group these as one large payment. The thing is, though, is that we're very smart investors. And we know that we're going to group those payments. But we also know that in life, if we have money put into a bank, that money, because we're really good investors, has to get some interest. It has to yield some sort of interest. So would it make sense to you that within this large payment that spans 3 years or 3 periods, really up to you. So within this large payment that spans 3 years, would it make sense to you that the first payment at year 1 compounds interest for 2 years, right? Because it's going to compound interest for 1 year, then another year, up until the end of this large payment. Does that make sense? That we have this large payment that's lasting 3 years, but the money we got on year 1, we're not just going to leave it, to chill in bed. We're going to make it accrue some interest. Okay, so that's the idea. So we know that 100 is going to accrue interest for 2 periods. Now, by that same token, do you guys understand that we're also going to accrue some interest from year 2 to year 3 for our second monies that we got, X? Does that make sense that we're going to let that compound for another period as well? Do I see some yeses in the chat? Cool, amazing. Right? But then what about this one? Because we're getting our payment at year 3, because we're getting 2x at year 3, is it going to have the opportunity to accrue any interest within our large payment? If we're getting it the same year, it's happening in the same year at the very end, right? At the end right here, does it have the opportunity to yield some interest? Let's say I give you money today. Can you get 20% compounded annually today? Or do you have to wait a year? I give you money today, will you have some interest on it? Right? Will you get that 12% that we get over the year? Well, I'm supposed to look here. Let's say I give you $400 today, and you could get 12% per year. But I'm giving it to you today. How much money would you have? Exactly, because my year didn't even end. I didn't even have a chance to accrue interest. It's literally same day type of thing. So what would be my answer here? What would I put here? What am I going to put here? Okay, perfect. We're on the same page. That's all that matters. All right. So before we continue, does everybody understand why our payment is equal to the following? Are we okay with that? Or was that too complicated? Because I have like 20 different ways of going about it. I think we're good. Don't see any questions. Good. So to reiterate, well, the reason why there's no exponent to x times 1.12 is because the exponent would be 1. It's compounding for 1 period. That's why. So you could put 1, you could not put 1, it's going to be the same thing, right? 1 to the power of 1 is equal to 1, 2 to the power of 1 is equal to 2 type of thing, right? Because it's multiplying just by itself. So that's the idea here. Okay, So now we have that. We have the first step. We're happy. We got that out. We have the first, portion. We have A as well. Now we're missing another important concept. Oh, okay. Well, let me give you an example. Let me show you what. All right, so I'm gonna show you in a second. All that I'm gonna do right now is I'm just gonna pause my share because I have to refresh my Notability. When it's been on for too long, it likes to kind of wild out a little bit. So just let me reopen my Notability. It's gonna make me make better notes, right? The longer it stays open, the uglier the notes, for whatever reason. I wish it was an exact science, but it's not. So with that said, I should be able to open it again now. Sorry about that. There you go. Okay, sorry about that. See how ugly my payment was? It was not looking nice. Just open. Okay, good. All right. See, makes all the difference. So now we have this large payment, okay? But our payment shall, it's spanning 3 years, right? It's spanning like 3 periods type of thing. Like we have period 1, 2, and 3. Now we know that spans 3 years, okay? So can you agree to me that if we have $100 a year 1, and we know we get interest every single year, can you agree to me that year 1 will have interest for those 2 periods from year 1 to year 3? Does that make sense to you? There, yeah, man, there you go. Exactly. We live for those. And then this one will only have interest for 1 year. And then this one was going back to itself, so it'll have no interest. There you go. So that's why we do it that way. So we have that out of the way. So now we have our payment. We're cool with that. We're happy. Let me ask y'all a question. Because our new period for our perpetuity that we've grouped up 3 years worth of payments, does it make sense to use 12% as our K? Does that make sense? If we're using our effective annual rate for something that lasts 3 years, does that make sense to you? Should we do that? Should we use 12% as our K if we know that only looks at 1 year? Can I have some answers in the chat? What are we doing? What are you doing? If this is looking at 3 years, can we use an interest rate for 1 year? Pranto says, I don't think so. Can I have some other answers? It's okay if you don't know. There's literally no wrong answer here. It's the portion of being able to kind of think about it. So Gior says an amazing thing. Convert it to an effective 3-year rate. That's a solid answer. Do people agree with that? That we should convert this to a 3-year rate? Hell yeah. Okay, good. So we know that. Now it's simple. So the formula, I've added it into your formula sheet, but it's really simple. All that you have to do is literally the following. To find the effective periodic rate, all that you have to do is the following. What will be my n here? What am I going to put as my n? What do y'all think? Pronto says 3. Julian, okay, good. We're all on the same page. So can somebody tell me what's our effective periodic rate for those 3 years? Can somebody give me that answer? What would that be? There you go. There you go. There you go. There you go. Thank you. Be sure, by the way, that when you're solving, this is they're not going to give you the answer if you do this on the exam, okay? When you're solving for the effective periodic rate for anything, exactly, that's why you can't. That's exactly why you can't. Because when you're solving for your effective periodic rate, always go to 4 decimal places or points, whatever, you know, because 0.40 only gives you 40%, but 0.4049 gives you 40.49%. So always make sure to go to 4 decimal points, because 40.49 is not the same as 40%. And you'll be surprised that when we're looking at perpetuity, that disparity right there is huge. Like for every percent point, you're literally flying in terms of valuations. That's really something important to know. So this is your answer. But I already had this answer in my course pack. So what I want y'all to see, I'm going to push you a little bit further. What would be our effective periodic rate if our EAR was 7%? And we were making payments, we were grouping a payment equal to 5 years. What would be our effective periodic rate? So you're doing the same thing as here, but you're going to change this and you're going to change this. What would be our answer? I just want y'all to be used to solving for this nonsense. So what would happen if we replace EAR by 7% and we change our N to 5? What is the answer? What are we looking at? I want y'all to get used to this type of thing. It makes it more fun. Because on the exam, it's not going to be the thing that I gave you in the course pack. It's going to be a little bit different. It's going to be tweaked. So what is the answer here? I need 3 people with an answer. What is it? Sarah says 0.4026. Julian says 0.4026. One last answer. Need somebody to confirm. Perfect. Amazing. Thank you so much. So now that we have that, the job is not over yet. Because we've discovered what our K is. We've discovered what our K is, but there's still one more requirement on our end. There's still one more thing that we need to do, and we need to do it right. Because we're not just solving for payment. We're solving for payment with X inside of it. Like we're solving for a missing variable. So what this will actually look like is as follows. When we're solving for the answer, is we're going to have PV. We'll zoom in. There you go. We're going to have PV equals payment over K. Thing is, though, is that we know that our payment is equal to a specific value. However, don't you forget that our payment is a big one. It's a large kind of formula, as you can see. Our payment is equal to 100 times 1.12 to the power of 2 plus x times 1.12 plus 2x. So that's what's going to be at our numerator. It's not just going to be a random amount. So we need to add the whole thing that we wrote prior. So we're going to have 100 times 1.12 to the power of 2 plus x times 1.12 plus 2x. And that's going to be over 0.49. All right, that's what we have to do. And that's the difference. That's what's going to actually give us the answer. So with that said, I'm going to pull a fast one on y'all. I'm going to tell you, I'm going to ask y'all, what is our x? Because right now we're solving for x. What is our x? Now that we have everything in a bundle. What is our x now that we have everything in a bundle? Huh. Interesting. Okay, so we have one answer. 123.74. You know when you get that random text message from a number you've never seen before and we're asking you like, hey, how's it going, bro? That's exactly what I just got. No clue who the hell it is. And I'm trying to find a non-insulting way to say, hey, who are you? So that's what I was looking at. But so we have one answer by Rosali. 123.74. It's in the ballpark. 123.65. Can I get another one? Tamara? Sarah got 123.65. Okay. So that is definitely in the ballpark. You want to be around this number. And these questions, you're fine with what you got. Like it's going to be a multiple choice. And obviously you're not going to pick 200. If you have your answer, you're going to pick something around 123.60. And on the exam, like back in the days, it was like A is this, B is 200, and like C was like 45 type of thing. And then D was like none of the above. So it makes it very obvious that you need to select this. So you're fine if there's like a small disparity, by the way, on an exam, like don't freak out. It's totally cool. So, okay, I think we have time for one more solid question. And I think I have them. Okay, so what we're gonna do is we're gonna do like a blitz. We're gonna run through questions because we want to cover all of them. You have them in your course pack, and those that you don't, I'm gonna give you the solution at the same time. So are we okay with the missing cash flow question? Did this make sense? Are we happy with that? If we see this on the exam, are we stressed out of our mind or do we feel comfortable? I want to have your opinion because this is a question that is definitely has been seen several times. Is everybody okay with that? Well, we're 15 here, so I'm sure. Okay, so Sarah says yes. Will this diagram be on the exam? That's an amazing question, Tamara. It's that sometimes they'll just write it out. They'll literally just write it out. Let me see if I could find an example for you. I'll show you what I'm talking about. I'll show you what it could be like on the exam as well. So on the exam, it could be something like this. Can everybody see my screen? I have this nonsense here. Yeah, cool. So on the exam, you may have something like this, where it says, suppose we have a series of cash flows. X dollars at the end of 3 months, $100 at the end of 6 months, X dollars at the end of 9 months. You may see some nonsense like this, okay? And you know that it tells you that, hey, this pattern is going to occur forever. So your responsibility when you see something like this, let me see if I could maybe pull up a noti thing. Let me see, sorry. I don't really use this usually, so I'm trying to see if there's a way for me to.
Would we have to convert that? I know it's a random question, but because it's compounded quarterly, do we need to change anything?
Well, in this case, X dollars is happening every quarter. I mean, I would because you're looking at a whole year, right? So you need to convert your compounded quarterly like interest rate to a effective annual rate. Oh. So that would be the nuance, all right? Okay. Because in this question, as Guyur said, if you look at your timeline, you're going to have like this is just one smaller timeline, but you're going to have X, then you're going to have 100. I'm so sorry, this looks like trash, but you're going to have this, and then you're going to have 100, I believe. So X 100, X 100. Yeah, so that would be for 1 year. And then it would be X 100, X 100. And the idea is that you want to look at this specific one as a payment, and then the other one as a payment type of thing. So it's really ugly. I'm so sorry, but you get the idea here is that you could be prompted with different perspectives, but it's still the same thing. You just have to make that extra step to put it within a timeline. But that said, yeah, you definitely want to put this on your cheat sheet, like the steps, like one by one. It's going to really make it easy for you. This one we already looked at. It was the idea of convexity for a yield curve. Very straightforward. As I said, it's always downward sloping. And the yield is, when the yield is high, the curve will be flatter. If the yield is low, the curve will be like convex. Okay. Just I'm trying to run through because we don't have so much time. So let me just add something for y'all. Give me a sec. Okay. So now if we look at this, because we only have so much time, let me show you a little bit what I would do if you had question 9. Okay, because we only have 5 to like 10 minutes, I do want to respect your time. I just want you to kind of get a sense of how the same steps are being repeated every single time, right? So in this question we have, I guess we'll look on the left, is that you're going to pay $800 into an account at the beginning of each of 20 years. So just like that, you know we're dealing with an annuity due. It's like guaranteed that we're dealing with an annuity due. And you know that the first payment is happening at T20. Then you know that you're going to let this amount compound for an additional 20 years. Okay. And then at the end of the 41st year, you know you're going to be able to receive a perpetuity from the account. All right. So why does this matter and how should you go about this? The reason why I'm saying this is important is because you see that this question has 3 different parts. Okay. It has 3 different parts. And these 3 parts are, first, the portion saying an annuity due, then the portion where you're letting cash compound, and then the portion in which you have a perpetuity. So you have 3 different portions to this question. Now, how do we go about that and how do we make sense of it? The first step, as always, is you need to build a timeline. You want to be able to build your timeline to be able to divide this within these 3 different segments. Why? Because these 3 different segments will require different formulas. And once you have the answer of the first segment, you'll be able to plug that in within the second segment. And then the same thing appends again. What you get from the second segment, you'll be able to apply within the third segment. Now, because we are pressed for time, I am going to walk you through this. So you know that a payment is happening at the beginning of each of 20 years, such that we're dealing with an annuity due. An annuity due, you look at the following formula. Now, because we're looking at how much money you'll receive into the future, there's no way we're going to use the present value formula. We need to use the future value formula. And that's exactly what we're doing. So we have 800 here up until T19. Now, the reason why we're stopping at T19 is because at T19, we literally made 20 payments. If you use your hand trick, you'll see that, okay, at T19, I made 20 payments. You know, I made that much, such that I still made a period of 20. Like I'm still looking at 20 effective periods because I made 20 payments. So your N will remain 20 because you made 20 payments. Just a trick to understand when you plug that in within your formula. All right. So that said, you're going to look for future value at year 20 because you're making 20 payments. And that's going to give you the following amount. Now, once you have that amount, you need to be able to compound that for an additional 20 periods. Why? Well, because the question tells you, hey, we're compounding this by an additional 20 periods. Now, the reason why this is really cool is because you realize that the same thing we did at the very beginning of today's crash is what we're doing again. There's often a set at which you need to compound interest for every single period. So what we're going to do is we're going to get FV40, right, at year 40, and that's going to be equal to our answer here, compounded at the interest rate of 14% for 20 years. And that's going to give us FV40. Now, the last real nuance here in this question, and it actually even took me like a day or so when I did this on my own back in the day, is to understand, well, what are we going to do with the perpetuity? Now, something I want y'all to understand is that the perpetuity formula really follows this trend here, okay? A perpetuity formula looks at P0 is equal to payment 1 over K. Now, what does that mean? That means that the present value at any given period of a perpetuity is equal to the payment of that period plus 1 over k. What does that mean once again? Is that if you look here, right, you literally see what we mean by this. Payment at period 4 divided by k is going to give you the present value of that perpetuity at period 3. So it's always a period removed. And I tried to illustrate that here, right? Payment at T1 is equal to the present value at T0. So now that we have our future value at year 40, we know that we're also looking at a perpetuity and we're missing payment, but we have FV40, so we have PV40, and we have our K, which is 14%. All that we're missing is the payment. So we can apply the same logic as payment 1 over K is equal to P0, i.e. payment 41 is equal to present value 40, or in other words, FV40 is equal to payment 41 over K. And that's why we have the following, right? We are taking the future value we have here, which is 1,140,912.12. That's going to be equal to the missing variable, the perpetuity payment, over the interest rate, which is K, 14%. And that's how you get 159,727 sorry, 0.70. Now, I know we didn't do it step by step. We didn't spend 20 minutes on the question, but with this, do you have any questions or any ideas? Was my explanation? Where can we find these notes? This answer is in your course pack, Joseph. So if you go up to, if I'm not mistaken, page 20 of your course pack, you're going to find the solution to this specific question. All right. So you could literally do that. And then for this question here, the dividend payment, you could go ahead and take a screenshot. It's not in the course pack, and you could see how to solve it. It follows the constant growth DDM formula. All right. Yeah, no problem, Pronto, for sure. No, for sure. And so this, by the way, are we okay if we take call it maybe like an additional 5 minutes to go through the different solutions? You can maybe even take a screenshot for you. The recording will be available to you. So technically this is in the recording, so you don't need to take a screenshot because it's going to be available in the recording, but you know, whatever. But yeah, so before we move on, is this question okay? You know, this idea of TVM with 3 different sections. Are we okay with this? Are we happy? Are we not happy? What are we doing? Yep, makes sense. What about somebody else? Yeah, we're cool. Okay. Good. Okay, so we have that in mind. Now, you could, as Pranto said, you could also send me a message if you don't understand something. I'm literally all ears until Saturday. And yeah. So ABC Inc. has a next dividend. Okay, so by the way, what does it mean, a next dividend? Is that D0 or D1? Somebody say that in the chat. Is that D0 or D1? Next dividend. Rosalie says D1. Guyur says D1. I need 2 more people. Okay, good. Yes, it means D1, literally. Okay, so we're here. We're not here. We're here. Okay. And the dividend growth has been consistent at 7%. Now, what does that mean? Now, you know me. I love to identify the formulas we need to use with the question. In this case, the formula we need to use is a constant growth DDM. All right. The constant growth DDM is literally the same thing as a growing perpetuity. Okay. It's literally D1 over K minus G is equal to present value. Right. So essentially P0 equals D0 times 1 plus G over K minus G. Now you're like, what the hell is 1 plus G? 1 plus G is literally the growth rate of 7%. So if we know we're applying a growth rate every single year, then by definition, we know that D1 is equal to D0 times 1 plus G. It kind of just makes sense in that way. So this question says that what is the stock price 5 years ago if investors require a 12% return? So the easy way to do this is just by applying the formula, by knowing that, well, hey, we're at T5 today. You're using your timeline. You know that T0 is 5 years ago. you know that T5 is today, and you know that next year will be at T6. So you know that the present value at year 5 is equal to D6 over K minus G. And we know that D6 is the next dividend because we're at T5 today, right? This is us today. And we know that the next dividend is one period after, so T6. So we know that 175 divided by 0.12 minus 0.07, so K minus G, will give us the present value at year 5 equal to 35. Thing is though, we're at year 5. So we're gonna assume that the stock price by then was equal to 1 plus K to the power of 5, right? As your denominator, then you're gonna divide 35 by that, and that's gonna give you your present value of 19.86. This one, don't hesitate to send me a message. It's kind of hard to not take the 20 minutes on if you really don't understand chapter 7. So don't hesitate to send me a message. I'd be more than happy to check it out. And there's also the recordings on it. And then for bond valuation, this one is just another one as usual. You could use the formula and it's going to give you the correct answer, which is 900, it's 5.3 the coupon rate. And then finally, we have the story of Lucas. This one is in your course pack, the story of Lucas. And essentially, what you're trying to do is you're trying to compare. Actually, let me show you where it is in your course pack. Let me show you, because it's in the course pack. I did spend some time doing it, so give me a sec. This one is in. Yeah, so this one's right here. Really simple, like it makes sense. We did the hardest questions, such that this one's going to be easy. And all you have to do is, here is just the formula sheet thing. But here you know that, hey, I'm giving money at a growing rate every single year. It's at the end of each year. Therefore, we're looking at a growing annuity. Let's use a growing annuity formula. Let's plug in those numbers that we know are growing every year. And that's going to give you your present value. It's very simple, very straightforward. You did the hardest part. Now, with this question, what you need to be able to do is, once again, what are we looking at here? You see growing, you see N, you see at the end of the year, you see payments, such that it's evident to you that we're looking at a growing annuity. So now that we know we're doing a growing annuity, we just need to find the formula. We found the formula. We just need to plug it in. We get the answer. Very, very straightforward. And yeah, I think that's, is it? I'm not sure. Could be wrong. Let's see. Yeah, so that's pretty much it. I don't want to steal too much of your time. But before you leave, one thing that I do want to say is that you saw the protocol, or like the optic I take when I do these questions. And I'm gonna reiterate it right now, especially this is crucial for exam 1. The first step you want to do is just take some time to read the question. Oftentimes, the reason why you're not getting the answer correct is because you didn't take the time to actually read the nuances of that question. Literally do like me, highlight them, write them down on paper, do whatever it takes to have all of them laid out in front of you. Now, once you've identified the nature of that question, you can now say, well, okay, there's only a specific set of different formulas I could use. Which one relates to this topic? When it's chapter 5, time value of money, it makes it very specific for you. It's literally a normal annuity, a growing annuity, and an annuity due, a perpetuity, like there's nothing else. And once you've identified which one it is, it's literally figuring out if we're looking at present value or future value. You only have to debate between 2 formulas. That's making your steps much easier. Now, once you've identified the formula you're looking at, all you have to do is plug those numbers in or look for the missing variable. So the idea is that you could have a very educated way of going about it that really reduces the time wasted and optimizes the optic and the perspective you're taking. For sure, it's high stakes, it's an hour, blah blah. But this is a difference between a 40 and a 60, or a 75 and a 90. Wherever you're at, this is going to give you easily a 14% increase in your grade because you're able to think about it the right way. So that's what I wanted to say. Now, another thing that I think is really crucial is take the time to redo the same questions on your own. It's okay. It's all right to redo the same questions on your own and just see if you're able to find the formula, and you can even have it on your side, but that you're able to go through it and kind of run through those gymnastics in a kind of efficient way. You don't need to time yourself, but you definitely need to test yourself, like challenge yourself. And then, as I said, I think it's crucial to do the Moodle questions on the tutorials. You already did the heavy lifting. Now just kind of fine tune yourself, really sharpen that blade of yours to really optimize your chances of getting, the best grade possible. Now, once you've done all these questions, identify the ones that you just kind of struggle with, right? Focus on them, because the other ones you're able to do. That's your forte. Don't focus in on what you're amazing at. Try to sand the edges of the parts that you're not too great at. Give yourself an opportunity to get that point. And then when you make your formula sheets, take that as another opportunity to kind of like sharpen that blade once again. Don't do it the morning of. Do it at least 24 hours before. Take some time to like understand your cheat sheet. Even if I were you, use a formula sheet that you have given by your prof or by myself, or even make your cheat sheet now and continue on using that while you're solving problems. Because then there's going to be a direct link to your formula sheet. It's not just going to be a bunch of random numbers. It's going to make sense to you. You're going to know what to look at. And it's actually going to create like some active recall when you look at the formula sheet. You're going to be able to look at all the different perspectives you've taken. And finally, when you do the exam, please remember to survey the exam. Look at the questions you got right, and it's going to be easy, light work. Get them out the way. Then double down on the harder questions. You'll be able to find the answers, or at least get a way better chance of getting it. Another part is that if you're doing multiple choice, be like intelligent with it. There are 4 options typically like 2 literally make no sense. Just like that, you optimize your odds of 25% of getting the answer correct to 50%. It's literally a flip of a coin if you really don't know the answer. Kind of try to use that to your advantage to kind of guess smartly if you need to come to that part, if you need to come to that end. If you have a multiple choice theory question, sometimes you could actually do a proof on the side. If it's a bunch of like random numbers, or like if they're using X and Y, blah blah. Well, if you have the formulas and you know that you could plug some random arbitrary numbers, well, at least you could try to like look at the relationship that they're trying to like portray within that theory question. That's just another way, if you have the time, if you have that luxury, to kind of like try to get that extra point, which is the difference between a 75 and an 87.5 if it's on 16, but it's on 15, so it may be different. And yeah, finally, I think all of you are amazing students. It's not rocket science. Everybody here was able to answer these questions. You needed the opportunity. Now that you have that opportunity, kind of run with it. Give yourself the best chance to be way above the average. And typically these exams are being curved either at the beginning of the semester, or like throughout, or at the end. So right now, if you beat the average, you're in really good hands. And that's the goal. And I'm sure you can do even more than that. To study for 220, I don't tutor 220, and this is funny, but I'm definitely going to recommend SOS Crash Course. I would definitely recommend the tutorials by like Anthony and stuff like that, because they do an amazing job covering the material. I think that's going to be crucial, and you could definitely check out SOS or the tutorials of the students at Moodle. They do a really good job. So yeah, I think all of you have amazing odds of doing well. If you have questions, do not hesitate to send me a message. I'll do my best to get back to you. And I think all of you will do amazing once again. And also, one exam won't change the whole semester. Trust me, the stakes aren't that high. Just work hard and you'll be able to do it. It's a long-term hedge. So yeah, recordings will be available on the ISMA Helps member area. Send me a message if you're not in it. We'll figure something out. And yeah, good luck to everybody. Thank you for the time. I appreciate it, and have a good evening.